Good afternoon, everyone. Thank you so much for joining this session. This is our O-level mathematics seminar 2026, and our program is we are going to have a word of prayer. And may I ask any volunteer school, may I get a volunteer from Charlin Secondary School to lead us in a word of prayer? Charlin Secondary School, unmute. And you pray for us. Charlene, unmute, and you get for us one student to lead us in a word of prayer.
Yes, everyone. Am I heard well?
Yes, you are very clear.
Yes, you are very clear. Yes, let's humble ourselves and we pray. Dear loving Father, allow me thank you this time. Thank you for the gift of life you've given us. Thank you for everything that you've done in our life since we started education up to this time, Father. As we are beginning this session, Father, may you please touch each and everyone's heart. Give us the wisdom and the knowledge. Whosoever and ever evils that comes from anywhere to cancel or to do anything with this session, Father, I come against them by the blood of Jesus Christ. As you stated in the book of Matthew chapter 18 verse 18, whatever is bound on earth will be bound in heaven. Father, I call upon your presence, I call upon your angels to be with us at the start up to the end. I pray all this trusting and believing in the name of Jesus Christ our Lord.
Amen. Thank you so much for the word of prayer. We want to welcome all the schools that have joined this session. Thank you so much for sparing your afternoon to be with us as we learn and share more about mathematics. In our session today, we are going to discuss, and we shall first give priority to those items that we were not able to discuss. However, we shall also touch other items such that for schools that were not here yesterday, they can as well be able to benefit. Before we start off the session, allow me to welcome the Principal Education Officer from the Ministry of Education to communicate to us and to officially start off this session. Mr. Ronald, you're most welcome.
Mr. Kaziba, I'm on the road. I don't know if you are hearing me.
Yes, you are very clear.
Okay, good afternoon, dear students. Good afternoon, teachers, and good afternoon, administrators. If there is anyone here, we would like to thank the good Lord who has brought us once again together. And we thank him for the fruitful day we had yesterday. We also commit today's day into his hands. I want to thank the schools that have allowed you to participate and to welcome everybody to this session and to wish all of us a good presentation. I will be following where I can, but I know that you are going to enjoy your afternoon. With that, I want to declare this session open. Thank you.
Okay. Thank you so much, Mr. Ronald. And we want to start off our session. I'm going to ask schools that are going to present kindly let us know through the chat which items you are going to be presenting. But Moyo Secondary School, you're going to be the first school to present. Kindly prepare. Then I know Popo, you are also getting ready, though I'm seeing your Sesame girls, kindly also prepare. Standard High School, Top Times High School, yes, and all those schools that want to present, kindly indicate in the chat which item you have been able to prepare for. But Moyo Secondary School, kindly prepare. You are going to be the first school to present for us that item. Now, in one of the areas that we need to understand as students as we approach the mathematics paper are what we call the elements of construct and what you should expect in each of the sections. We know very well that section A is a compulsory section, and some of the topics that are within that the first item are as shown below. What does it mean? It means that during your preparation, as you prepare for your paper, for item 1, you must be well conversant with these topics. When you look at number bases, you'll notice that this topic here, you were able to cover it in senior 1. When you check out fractions and percentage, this is still senior 1. When you check out numerical concepts, this is what you covered in senior 2. This one you covered it in senior 2. This one you covered it in senior 1. And then this is senior 3. So when you notice, you cannot see that the 3 topics are from senior 1, meaning that you must be well grounded with your senior 1 work. But from each of these topics, there are particular things that you must know. Here, I want you to take note that when you are looking at number bases, always ask yourself, do I know how to convert from one base to another? Do I know the different base names? If they use binary base, do I know which base? Because sometimes they may just use the word binary. And then you ask, which kind of base is that? They may use another what? Another name. So mean that here you must be well conversant. Which name stands for which particular base? That even ask yourself, can I convert from one base to another and from the other base to the other? Then that is under number bases. When it comes to fractions, percentages, and decimals, ask yourself, if I have a quarter, am I in position to convert this a quarter to percentage? Do I know that I have to say a quarter times 100 and this is 25%? Do I know how to convert now this back to decimals that this is 0.25? Now, that is under fractions, percentages, and decimals. Now, when still comes fractions, percentages, and decimals, now this topic is always combined with the element of working with integers. They are going to be telling you that 40% of the money, then meaning that now you need to know that 40% of that particular money. Remember, under working with integers, this is where you're going to look out for how we convert from words to figures, from figures to words. So the item may be looking out for, are you in position to write from words to figures? Are you able to stretch how to write a billion, how to write a trillion, how to write a million, given in words to figures or figures to words? And that's the main thing you looked at when you are looking at working with integers. Now that means that now these two topics can come in the same scenario, meaning that you need to know how to deal with a decimal. How do we multiply decimal? Sometimes even when it comes to decimals, they can give you a recurring decimal 0.2222 and they want you to have it in an exact form. When it comes to numerical concepts, when it comes to surds, here you need to know, do I know how to multiply the surds? Do I know how to add the surds? Do I know how to subtract the surds? Do I know how to rationalize? Because here you're going to find items under surds that are going to be involved in calculating the area, whereby they have given you the area in surd form. Let me say 2 plus root 2, and maybe you have gotten your length as this. Now here they are testing you. Do you know how to multiply surds? Do you know that when you multiply surd times the surd, you get a surd? Then that's the concept they are going to be looking out for under the surds. When it comes to indices, now here you need to be well conversant with the rules that under indices, what are those rules? That if I have a number to any base, when the bases are the same, it means I will add the powers. That when I'm dividing 2 digits whereby this and this, then I need to know that here I'm going to be subtracting. Now you need to remember your knowledge of indices. Then when it comes to ratios and proportions, when it comes to item 1, dear students, here you are mainly going to be tested on sharing. They are going to tell you that Catherine and maybe Angel were having something, and they were able to share in the ratio of 3 to 2. How much did this person get? How much did the angel get? Now here we are looking out for, do you know how to share when you are given ratios? They will give you a scenario whereby they have told you that maybe the parent wants to pay fees, but he wants to pay in installments, but in this amount and this amount. Then here we are testing. Do you know how to use your knowledge of ratios to share things equally? Now that's what we are looking out for. But also a scenario can come whereby they have given you 2.5 in the ratio of 3. And then you ask yourself, how do I deal with such? Then you need to remember your knowledge of ratios. That here, the best way to do it is to first convert this. And then after converting it, you get the total ratio and then you continue to work out. So that is basically about that. Now, when it comes under the second element, which we call the patterns and algebra. Under patterns and algebra, this is where you're going to mainly be defining. You're going to be saying, let x be equaling to this. Under patterns and algebra is where we deal mainly with equations, is where we deal with what we call expressions. So these ones are going to be found under patterns and algebra. This is where you're going to be forming your equation and you're going to be finding the unknown. And whenever you talk about an equation, do not forget you must have an equal sign. Whenever you talk about an expression is just anything like this, but without an equal sign. When you talk about a term is just 3y. Now, all that is found under patterns and algebra. When it comes to sequence and patterns, this is where they are going to be testing you. That if they will tell you that the parent visited the child maybe on day 2, the parent came back on day 4, the parent came back on day 6, and then they may ask you to generate the general rule on how, or you predict when the parent is expected to come back at school. So here they are testing you. Do you remember the general rule? Do you remember how to generate the general rule using your knowledge of senior 1 when we are looking at sequence and patterns? When it comes to algebra 1 and 2, here you started with it in senior 1. This is where you looked at how to deal with simple linear equations. When you reached senior 2, you looked at what we call quadratic equations. Now that is under algebra. Now under algebra, here you are going to find yourself that you are going to apply concepts concerning areas, more so when you are going to be meeting quadratic equations. And here, members, please take note that when it comes to solving quadratic equations, it is okay. You can have your equation, maybe you are using this approach of the bulldozer. It is okay. This is very, very fine. But please take note that when they are scoring, when they are giving a mark, they do not mark the formula, but they look out for, as the child is substituted in well, is the substitution okay and is the formula okay? So they award you a point or a score for correct substitution and correct values substituted in the correct formula. In case you find yourself forgetting the formula, please check out on the mathematics book, ask for a logbook, and then you can have that formula. But here we do not award a mark for a formula, but we look at correct substitution in the collective formula with the collective values. Now, when it comes here under quadratic, even they may ask you to draw or to come up with a curve. Now you need to know, how do I solve? In case they have given me a quadratic equation, they want me to come up with a curve. How do I come up with a curve? Do I know how to obtain the maximum point? They may tell you a ball was kicked and this particular ball reached the maximum point. And then the question may ask you, determine how far the ball reached. Now that means they are indirectly asking you, how do you obtain the maximum the maximum what? The maximum point. Now, we have what we call simultaneous equations still in the same element. Now, under simultaneous equation, when you are looking at patterns and algebra, this is where you can use your methods. This is where you're going to be finding scenarios whereby they will tell you that this particular person bought maybe apples, bought 5 apples and bought maybe 2 oranges at 5,000. In another, maybe the next time he came back to the hotel, he found out that 3 apples and 2 oranges were at this amount. Then they may ask you, what could be the price of those particular items of the individual item? Then that means they are testing you on how to solve simultaneous equation. Now here, when you are choosing which approach to use, you can feel free to use the elimination method, feel free to use the substitution method, feel free to use the graphical approach. Those are the best methods that suits this element of construct. Now, when it comes to inequalities and regions, here what you need to remember is, how do you shade? Do you shade the unwanted region? Do you remember how to shade the unwanted region? If yes, then that means it's okay. Whenever you reach the point of shading, always shade the unwanted region. Then here also we can look at solving. Do you remember that whenever you meet an inequality, let me say this is an inequality, and you have reached the point of dividing by negative, do you remember that the sign has to change at this point where you divide? Then that is now what you need to know when it comes to inequalities and region. Do you remember how to represent them on a number line? That when I have, let me say I have x is greater than 2, here I'll use an open circle to show that 2 is not inclusive. We can have mappings and relations, equations of lines and curves. Now these are the points, or these are the things you can find under that element of construct. Now we have what we call data and probability. Now under data and probability is what is mainly being tested for is, do you know how to represent data? Now when it comes to data collection and statistics, these two, here you must specify how are you presenting your data, that I'm using a frequency distribution table. Then clearly indicate the method of presentation is a frequency distribution table. In case you are dealing with set a Venn diagram. In case you are using matrices, say a matrix showing the data for this and this. In case it is probability, indicate the approach that I'm using, a probability tree diagram. Now those are what we call the approaches or methods of presentations of data. Now when you are dealing with these ones, please define what you are using. In case the scenario has not defined for you, clearly indicate that summarize your data. Let A equals to the number of people who take art. Let S be the number of people who take science. If it comes to matrices, clearly show that when I'm dealing with a matrix, I'll have to label my matrix that this was P, this was Q, this was R. This was for week 1, this was for week 2, and then put your entries in the matrix very well. And also here, please make sure you read, because they'll ask you what clearly organize the data giving the order, meaning that you need to know that always indicate the order, that your order is given by row by column, and then indicate that how many rows are this is 1, 2, this is 2, and how many columns? These are 3. So always read to understand the question. And when you are dealing with matrices, please avoid putting your brackets. Let me say you label and you put your brackets. This one means that P and Q and R are also part of the entries, which will make your work wrong. So never, always have the labels above the matrix. When it comes to set theory, please do not forget, always draw 2 diagrams. First have the diagram for the unknowns only. Then go on to have another diagram where you have the unknowns you have been able to find. Here it is okay, have your S.4 minus x and the rest. Then when it comes to this accurate diagram, indicate clearly the values you have obtained, and then that is your accurate diagram where you're going to obtain other values. When it comes to the probability tree diagram, indicate the tree and indicate what is contained here, that these are red, these are blues. Indicate that this is now my basket that contains the balls, and then clearly put the heading, put a title that this is a probability tree diagram. Now that is what. In case it comes to graphical work, please label your graph very well. Label what do you have here, what do you have here, then come up with any kind of graph. Here the graphs can be distance time graphs. You looked at graphs in senior 2. So that one is also another approach for presentation. Now, when it comes to geometry and measures, here the major things you need to look out for is the accuracy. Under geometry and measures, accuracy is very key. You must be very accurate. In case you are making any sketch for any diagram, make sure that your sketch is talking. It depicts what is going to happen in real life. So when you are making a sketch, let me say you have put here that this is 2, and then you come and you put that this is 8 and this is maybe something. Please, when you check out, you notice that this distance is 2, this is 8. But in reality, 2 cannot be bigger than what? 8. So when you are making your sketches, make sure that the sketch depicts what can happen. That if this is 8, you can approximate that maybe this will be about 7. So let that distance show clearly on your scale. Don't do it as if you are doing rough work. Even if it is rough work, please show. And I want to ask you, dear students, that let's not have rough work. If you feel you are doing rough work, use a pen and do that work. Never write in a pencil, because sometimes you may be caught up with the time and you had done your work in a pencil. What you have to do, even if it is rough work, you write it there. It will be squared in case time catches you up when you have not finished. So, and when it comes to your sketch, here we put the values, the way you have extracted them from the diagrams, that these are 7 kilometers, these are maybe 8 kilometers, and then after here, you show us how you are converting. Now, these are some of the topics that we have under item 5 and item 6. And please do not forget that here, when it comes to geometric construction skills, you need to know, do you know how to inscribe and circumscribe? Do you know how to find the areas? When it comes to bearings, do you know how to use your protractor to find those particular bearings? And do not forget that bearings can be mixed with the trigonometry. A number can come. When you look at the seminar items we had, you may have noticed that you could do that bearing using your knowledge of trigonometry, using the sine rule and cosine rule. Next time they may say using calculation approach, and they don't want you to draw it on a graph. Mean that now you need to know, if I'm calculating, do I know how to use the sine rule? Do I know how to use the cosine rule? Do I know how to find the area? Because you looked at the area. In case you find that the angle here maybe is 6 and this is 6 and this is 4. Do you know how to find the area? That maybe I will use B sine of A. Do you remember how to find the area when you have an angle? And that you are not going to use a half base times what? Height. Now, those are things that you need to know. When it comes to matrix transformations, please take note. Do you know how to do the enlargement? Do you know how to find the scale factor? Do you know how to find the center for enlargement? Do you know about rotation, angle of rotation? Now, those are the things that you need to know. Now, under nets, areas, and volumes of solids, here we can mix this area with the 3 dimensions that you cover in senior 4. We can mix the nets and the lines and planes in 3 dimensions. So here we look at all figures that can be applied in real life. It can be a prism, it can be a pyramid, it can be a cylinder, as long as a figure can be applied in real life. And you need to know, how do I get the angle? In case I have a cuboid, how do I get the angle between the planes? Because next time when you look at the roof, next time they may tell you to find the angle between the 2 planes. This is one plane and this is another plane. Do you remember how to find a plane? Do you know how to find the angle? Do you know how to find the length of this? So that one will go and connect with lines and planes in 3 dimensions. So that is briefly what I wanted to, before now we start our first thing. But always make sure that you plan for your work. Allow me now to invite our first school that is going to present, Moyo Secondary School. Kindly unmute and take us through the first presentation. Okay, over to you, Moyo.
Yes, we are sharing our screen.
Hello, fellow students. My name is Angela Bridget, a candidate from Moyo Secondary School, coming to take you through item 13 under the construct of data and probability. Here we go through the question. That a television company is organizing a quiz competition for secondary school learners. In the first round of the competition, a contestant must answer at least one question correctly in order to qualify for the second round. Each contestant may be asked at most 2 questions. A contestant who answers the first question correctly automatically qualifies for the second round and is not asked another question. However, a contestant who fails the first question is given a second question. A contestant who answers the second question correctly qualifies for the second round, while one who fails the second question is eliminated from the competition. The organizers analyzed past performances and established that the probability of a contestant answering any question correctly is 0.6. The company has only prepared speech and learning materials for contestants in the second round if the probability of contestants qualifying is greater than the probability of contestants being eliminated. Task: help the organizer to Part A is saying that present the possible outcomes of the competition and their probabilities in a suitable form. Okay, here is what we came up with. First, we have the data collection and we define the variables. We let C represent the probability of a contestant answering correctly, and W represent probability of a contestant answering incorrectly. Here we have, in the scenario, we were given that the probability of a contestant answering correctly is equals to 0.6. Therefore, for us to get the probability of a contestant answering incorrectly, we are going to subtract 0.6, which is the probability of a contestant answering correctly, from 1. We'll be able to get 0.4. Then we have our tree diagram for the experiment. The first attempt, remember in the scenario we were given that the competition, we are going to ask at most 2 questions. So we start. In this tree diagram, we're having 2 possibilities, that a person either answers the first attempt correctly and qualifies, where the probability is equals to 0.6. Or a contestant answers the first attempt wrongly, where the probability of answering the first attempt wrongly is equals to 0.4. Therefore, after taking the first attempt, then we go to the second attempt, where a person who fails the first attempt is given chance. In this second chance, there are also 2 possibilities, that you either answer the second question correctly or answer this wrongly. And a contestant who answers the second attempt correctly qualifies for second round, and the probability for answering correctly is equals to 0.6. Or a person who fails or answers wrongly in the second attempt will be eliminated, which means the person will not go for second round, and the probability for answering wrongly is 0.4. Then we go and identify the probabilities in the branches. The first branch, we have a person, a contestant who answers the first attempt correctly, where the probability is equals to 0.6. Then the second branch is a person who in the first attempt answers the question wrongly and in the second attempt answers the question correctly, where the person qualifies, whereby the probability of a contestant who failed or answers wrongly in the first attempt times the probability of a contestant who answers in the second attempt correctly is equals to 0.4, which is the probability of a contestant who answers in the first attempt wrongly times 0.6, which is the probability of a contestant answering correctly, where we'll be able to get 0.4. Then the last branch, we're having a probability of a person who fails in the first attempt and in the second attempt, which means these contestants have failed in both attempts. Therefore, the first attempt, the probability is 0.4, where the contestant answers wrongly. And the second attempt is also, the probability is 0.4, where the contestant again answers wrongly, whereby we multiply the probability in the first attempt and in the second attempt, which is 0.4 times 0.4, where we'll be able to get 0.16. The outcome. We have the outcome and we came up with a table where we have the outcome and probability. The first column is having the qualifying in the first attempt. The probability for qualifying in the first attempt is equals to 0.6, because this person, when was given one question, the person has just answered it correctly, whereby the probability is 0.6. And in the second column, the person qualifying in second attempt. This is where a contestant fails the first attempt and answers correctly in the second attempt, where we'll be able to get 0.24. Then eliminated. This is a contestant who failed both attempts, was given the first attempt and fails, the second attempt and fail, where the contestant is eliminated and cannot go for the second round. That one is the probability of a contestant answering wrongly times a probability of a contestant answering wrongly, where we'll be able to get 0.16. Then part B is saying that determine whether the preparation made for the second round are likely to be enough. Give a reason for your answer. The company prepares for the second round only if probability of qualifying is greater than the probability of elimination. Therefore, when you go through the answers, the probability of qualifying is equals to 0.6, which is the first attempt, where the first person is given the chance, the first attempt and answers correctly, plus the second attempt plus 0.24, where the contestant first answers wrongly and in the second attempt, the contestant answers correctly, which is 0.24. When you add this, you'll be able to get 0.84, which is the probability of qualifying. And the probability of elimination is equals to 0.16. If you compare these two, 0.84 is greater than 0.16. Therefore, the preparation made for the second round are likely going to be enough because there is 0.84. If in percentage you are going to get 84% chance that a contestant will qualify for the second round compared to only 0.16. If in percentage we are going to get 16% chance of elimination. Thanks for listening.
Thank you so much for the wonderful presentation, Moyo. Let's invite in questions. In case you have any question, kindly raise up your hand and then you pose the question. In case there is anything any explanation that you may need, kindly raise up your hand and then you can be okay. I think from the members, I think everything is very okay. So thank you so much, Moyo, for that great presentation. So I want to, before Moyo, you go in for your second number, allow me to share something concerning that, something small. Now, when you are handling probability, dear students, be very careful with the wording, more so when you are making a conclusion. When you are making a conclusion. So what happens is that, okay, like when you are dealing with the probability, we have what we call a probability scale. Now, a probability scale is the one which informs you which kind of words are you going to use in your explanation. When you are making a conclusion, whenever you meet a scenario, always ask, you must have the two things. You must have a conclusion and you must respond back. Or you can take a decision. Depending on the scenario, there are scenarios where where you need to compare two values, conclude, and then decide. So I always encourage that first make your conclusion on one line, and then after make the decision. But as you are concluding, please pay attention that when we have a probability scale, here we have 0.25. Here we have here is where we have 0.75. Now, in case you get a probability that is above 0.75, that probability is very likely to happen. Now, when you are making your conclusion, use a word like very likely. Likely to happen is when you are at around 0.75. But if the probability goes beyond 0.75, then that is very likely to happen. Now, when you look at the conclusion that Moyo made, they use the word likely. But when you look at the probability that they were able to obtain, which was 0.84, you notice that that probability was above 0.75. So now the word we could have added would have been very likely to do this and the other. So that is how you can make your conclusion. Next time it can be in fractions. You can have a fraction that you are comparing. Let me say this is a quarter, this is a half, this is 3/4, and this is 1. Next time you may find that you are dealing with percentages. So also you need to know which words can I use, because also that one matters as you make your conclusion. So as we make our conclusion, now like for the past one, I would expect that you can make your conclusion that the preparations made for the second round are very likely to be enough, because the probability that a contestant qualifies for this is 0.84, which is greater than the one for elimination of 0.16. So that's how you can make your conclusion. But be very mindful of the words. In case you have decided to use decimals, stick to decimals. In case the question had percentages, then you go on and use the percentages. Okay, thank you so much, Moyo. Moyo, we can have the second presentation.
Item 14, right?
Okay, fellow students, my name is Dora Donna, a candidate of Moore Senior Secondary School. Here to take you through item 14, which under the construct of data and probability. Here goes. To make our scenario easy, our item 14 is about a businessman who wanted to import his urgent goods from China to Jinja, and he received transport proposal from two logistic agents. First agent proposed the air transport, where the goods will leave China at exactly 9 a.m. to Guangzhou, where it will cover a distance of 1,200 under the speed of 240 kilometers per hour, and the time is not given. In Guangzhou, it will spend 4 hours in clearance. From Guangzhou, the goods will be fleet to Addis Ababa, covering a distance of 7,200 kilometers under the same speed, which is 240 kilometers per hour, and the time is not given. In Addis Ababa, the goods will spend 3.5 hours in clearance. From Addis Ababa, the goods will be fleet to Entebbe, where it will cover a distance of 3,500 kilometers under the speed of 200 kilometers per hour. The time is not given. And it will spend 5 hours in clearance. And from Entebbe, the goods will be transported to Jinja using a truck, where it will cover a distance of 75 kilometers under the speed of 50 kilometers per hour. The time is not given. And if we're to take in our scenario that agent one tells according to the total flying time, excluding all clearance hours. Using the active flying times only, they charge first 30 hours, ceilings 50,000 per hour, and the next 15 hours will be charged 80,000 ceilings per hour. And if you are to move further in that condition that any additional active flying time exceeding 45 hours will be charged 100,000 per hour. And they offer free transport from Entebbe to Jinja. And if you are to continue to go through the scenario that agent to propose seed, and after the seed, the goods will be transported by a train, where the goods will leave Guangzhou on a sea to Mombasa, covering a distance of 8,800 kilometers under the speed of 40 kilometers per hour. The time is not given. And spend 24 hours in clearance. From Mombasa, the goods will be transported to Jinja on a train, covering a distance of 1,350 kilometers under the speed of 80 kilometers per hour. The time is not given. If to check on the charge or the cost of Agent 2, that the charge ceilings 2,500 per kilometer traveled. And they also offered a discount of 12% if the total transport distance exceed 9,000 kilometers. And our tax one required us to advise the businessman on the most suitable logistic agent for transporting the goods and give a reason for your answer. To advise the businessman on the most suitable logistic, we need to compare both agents on two critical factors, that to say the time and the cost. For this reason, we are going to start with agent 1. Since agent 1 is going to charge them on total active flying time, we need to get the time. From the scenario, the first flight was from China to Guangzhou, where they covered a distance of 1,200 kilometers and a speed of 240 kilometers per hour. The time is not given. So we are going to get the time from the formula that time is equals to distance divided by speed. Where we say 1,200 kilometers divided by 240 kilometers per hour, where we'll be able to get 5 hours. From there, we move to the second flight that is from Guangzhou to Addis Ababa, where the plane was able to cover a distance of 7,200 kilometers under the speed of 240 kilometers per hour, and the time taken is not given. So from the formula, time is equals to distance divided by speed. We will say 7,200 kilometers divided by 240 kilometers per hour. We will be able to get 30 hours. And the third flight from Addis Ababa to Entebbe. From Addis Ababa to Entebbe, they covered a distance of 3,500 kilometers under the speed of 200 kilometers per hour. The time is not given. So for us to get the time, we are going to say time is equals to distance divided by speed. We are going to say 3,500 kilometers divided by 200 kilometers per hour. I will be able to get 17.5 hours. After that, you are going to get the total flying time, whereby you add the first flying time with the second flying time and the third. Well, we are going to add 5 plus 30 plus 17.5. We'll be able to get 52.5 hours, which is our total flight time. And after getting the total flying time, we are also going to get the total clearance time. From our scenario, at first they spent 4 hours in Guangzhou. Well, during the clearance running, 3.5 hours, and also spent 5 hours. That is to follow from our scenario. Therefore, we're going to say 4 plus 3.5 plus 5. We'll be able to get 12.5 hours. And that 12.5 hours is our total clearance time. And there is a statement that the goods also transported to Jinja by a truck covering a distance of 75 kilometers at an average speed of 50 kilometers per hour. We also need to find the time taken on road to Jinja. Since the distance is equals to 75 kilometers and the speed is equals to 50 kilometers per hour, the time is not given. We're going to say time is equals to distance divided by speed, whereby we're going to say our 75, which is our distance, over 50 kilometers per hour, which is our speed, we'll be able to get 1.5 hours. After getting that, we are going to get the total time taken by agent 1 by adding all the time, including the total flying time plus the total clearance time plus time spent while traveling to Jinja from Entebbe. We'll be able to get 66.5 hours. After getting the total hours taken, since for us to advise the businessman, we need to know the number of days taken by agent 1. Since in one day we have 24 hours and our total time taken by agent 1 is equals to 66.5 hours. For us to get the day, we are going to say 66.5 hours divided by 24 hours in order to get the number of days. Well, we'll be able to get 2.77808, which is approximately 3 days. Since agent 1 took approximately 3 days, the goods were delivered within the required timeline of 15 days. After that, we're going to calculate the cost based on the flying time as required from the scenario. From their condition that they are going to charge that the first 30 hours were charged at ceilings 50,000 per hour. For us to get the cost of 30 hours, we're going to say 30 times 50,000. We'll be able to get ceilings 1,500,000. And then next, in their condition, they stated that next 15 hours were charged at ceilings 80,000 per hour. For us to get the cost charged on the 15 hours, we're going to say 15 times 80,000. We'll be able to get ceilings 1,200,000. Before we proceed to get the cost of the remaining hours, we first need to get the remaining hours by saying 52.5, which is our total total time taken by agent 1 minus 30 plus 15. We'll be able to get 7.5 hours to be our remaining hours. And to go back to the scenario that any additional flying time above 45 was charged as ceilings 100,000 per hour. Therefore, we're going to get the cost of 7.5 hours by multiplying 7.5 by 100,000. We'll be able to get ceilings 750,000. And after that, you are going to get the total cost for agent 1 by adding all the cost of the hours. We'll be able to get ceilings 3,450,000. And after that, we are going to agent 2, which propose seed and rail transport. Time for the seed, that they cover a speed of 40 km per hour and a speed of 8,800 kilometers. The time is not given. So we're going to get time from the formula, that distance divided by speed, where we're going to say that our 8,800 kilometers divided by 40 kilometers per hour. We'll be able to get our time as 220 hours. Time for the time taken by the goods well on rail, on train. And the speed is equals to 80 kilometers per hour and covering a distance of 1,350 kilometers. The time is not given. From the formula, that time is equals to distance divided by speed. We're going to say 1,350 kilometers divided by 80 kilometers per hour. We'll be able to get 16.875 hours. After getting the time taken, well, transporting using sea or railway transport, we're going to get clearance time from the scenario that they spent 24 hours on clearance. And after getting that, we need to get the total time taken using agent 2. By adding 220 with 16.875 plus 24, we'll be able to get 260.875 hours. After getting the hours, the total hours taken by agent 2, we also need to get the number of days. Since there are 24 hours in a day, for us to get the number of days in it, 260.875 hours, we are going to say 260.875 hours divided by 24. We'll be able to get 10.87, which is approximately to 11 days. Since agent 2 took approximately 11 days, the goods were delivered within the required timeline of 15 days. After that, we're going to get the total distance from agent 2. Since their charge depends on the distance, And if you are to follow from our scenario that the first distance is 8,800 and the second distance was 1,350. That means we're going to add 8,800 with 1,350. We'll be able to get 10,150 kilometers. And depending on their condition, depending from their condition, that they charge 1 kilometer ceilings 2,500. Therefore, we need to get the cost of 10,150 kilometers by saying that 10,150 times 2,500, we'll be able to get ceilings 25,375,000. Since total distance of 10,150 kilometers is more than 9,000 kilometers, there will be a 12% discount applied. Because if you are to check on their condition that they will offer 12% discount when the total distance exceed 9,000 kilometer. From there, we need to get the discount, the amount of discount. By saying 12% of the total cost, which is ceilings, 25,375,000. Whereby we're going to set 12 over 100, which is the total percentage, times 25,375,000. We'll be able to get ceilings 3,045,000. And for us to get the total cost for Agent 1, we're going to say, for Agent 2, we're going to say cost on total distance minus discount, which will be your 25,375,000 minus 3,045,000. We'll be able to get 22,330,000. If you are to compare ceilings 3,450,000 with the ceilings 22,330,000, the cost for Agent 2 is greater than the cost for Agent 1. So, based on the time taken and the cost incurred, the businessman shall choose Agent 1 because with Agent 1, the goods were delivered in few days and with less cost of ceilings, 3,450,000 compared to Agent 2, which took more days of 11 days and also incurred more cost of ceilings, 22,330,000. Thanks.
Thank you so much, Moyo Secondary, for the wonderful presentation. Do we have some questions from the participants? In case you have a question. Okay, I feel they have understood. When you look at their conclusion, dear students, make sure that your conclusion has the evidence. Why are you saying so? Now, when you look at their conclusion, they have told us why they have chosen the agent number one, but they have also been able to represent, to show us why. So they have showed us the conclusion and they have made a decision. So make sure that your conclusion also communicates. Here, remember, you have to communicate. You must respond to the task. Why are you choosing this agent? What are you basing on to choose this particular agent? And thank you so much for making the comparison such that someone can be easily see why the other agent one is better than the other. Thank you so much, Moyo Secondary School, even for using the ICT tools. We shall be inviting you. I know you have other numbers that you will be coming in to present to us. Thank you so much. It was a wonderful presentation.
Most welcome.
Yeah, most welcome.
Okay. Maybe to add on, members never forget to have units. When you find that units have been used, please go on and have those units indicated there. Make sure that the units are always indicated there. So that one will give you an advantage. Thank you so much. What you are seeing on screen, those are students from Moyo Secondary School. Okay. Now we are going to go on to another school. Moyo has presented number 13 and 14. Okay, I want to know which school is ready to take us through the second presentation. Paloketo, kindly let me know whether you are set. Paloketo, and also Popo Anak, Palabek. Okay, in case your school is ready, kindly indicate in the. Okay, in case you. Okay, Anak, kindly let me know whether we are set. Poloketo, I'm not seeing. I'm not. Palabek, also kindly let us know whether you are set. Yes, Anak.
Yes, good afternoon.
Yes, good afternoon, sir.
We are sorry, sir. We shall not be able to present.
Okay. So, because I know Moyo has another presentation, Moyo could be preparing that presentation for another number. I know you had quite a number you had prepared for. As I check on Palabek,
So which one?
Yes, sir.
Palabek. Oh, this is Moyo.
This is Moyo.
Okay, you could be preparing for the other presentation. I know you had another number that you had
All right.
prepared for.
Okay.
Okay. Any school that is ready? I fail to get Parabek. Okay. I think I'm going to take back. I'm going top times Chengera. Top times Chengera. Okay. So over to you, Moyo. Over to you, Moyo, to take us through another number. Other schools, feel free to prepare. Yes. Feel free to prepare any number as long as we have not yet discussed it now. Teacher David, I know you had prepared for number 14, but we can have the students come in for another number.
Which number?
Not 20, that one did.
9.
Yeah. But as long as we have not discussed. Nine. Okay. Hello, students. Once again, my name is Jora Donna, a candidate of Moyo Senior Secondary School, coming to take you through item 9 under the construct of data and probability. Okay, the scenario says due to the increasing number of road accidents associated with mechanical failure, the Ministry of Work and Transport intensified vehicle inspection exercise in selected regions of Uganda. The ministry is particularly concerned about vehicles operating with multiple defects because such vehicles are concerned highly risky to road users. A team of engineers was assigned to analyze inspection findings from one region after concerns were raised about the condition of vehicles operating along major highways. According to the ministry guidelines, a new inspection center shall only be considered if less than a half of the inspected vehicles are found with only one defect. During the inspection exercise, 94 vehicles were randomly inspected and selected and inspected for faulty tires, faulty steering system, and faulty bodyworks. The inspection findings shows that 34 vehicles had faulty tires, 40 had faulty steering system, and 29 had faulty bodywork. Some vehicles were found with more than one defect. In particular, 7 vehicles had both faulty tires and steering system. 6 had both faulty steering system and bodywork, while 11 had both faulty bodyworks and tires. The engineers also established that 11 vehicles do not have any of the 3 defects under investigation. Task A. Using a suitable representation, support the engineers in establishing the exact number of vehicles that had all the 3 defects. Now here we're going for the response for A. Since the defects all start with faulty steering system, faulty bodywork, faulty tires. Therefore, we need to select a suitable variable to represent each defect. So we have chose to let T represent defect for faulty tires and S represent defect for faulty steering system and B represent defect for faulty body system. After defining the variables, we are going to collect data from the scenario. That's our data collection. From the scenario, that the number of vehicles inspected is equals to 94, which is our universal set. And the number of T is equals to 34. Number of S is equals to 40. Number of B is equals to 29. And number of T intersection S is equals to 7. Number of B intersection S is equals to 6. Number of B intersection T is equals to 11. Number of T union B union S complement is equals to 11. Since the number of vehicles with all the defects is not given, so We are going to let the number of vehicles with all the defects to be in a letter. From my side, I have let the number of T intersection B intersection S to be X. From there, we move to drawing our Venn diagram representing the data from the scenario. That the number of universal set is equals to 94. Number of T is equals to 34. Number of S is equals to 40. Number of B is equals to 29. And since we let the number of vehicles that had all the three defects to be X, that means the number of T intersection S intersection B is going to be X, which is the middle region. And if you are to see from the scenario that number of T intersection S is equals to 7. And since part of T intersection is X, we are going to say number of T intersection S only is going to be 7 minus X. Again, from our data, that the number of B intersection S is equals to 6. And since part of B intersection S is X, we need to get the number of B intersection S only by saying 6 minus X. And after that, we also find out the number of T intersection B is equals to 11. And since part of the region of T intersection B is X, therefore we are going to get the number of T intersection B only by saying 11 minus X. And from our data, that the number of T union S union B complement is 11, which is the number of vehicles that do not have any of the three defects. From there, you need to get the value, you need to get the number of T only. Since the total number of vehicles that had faulty tires is 34. We are going to say 34 minus 7, open bracket. We are going to say 34 minus open bracket 7 minus X plus 11 minus X. That 2X in the red color are going to cross, cause negative plus positive, whereby we will be left with 34 minus 7 plus 11 minus X. And after that, you are going to get 34 minus open bracket 18 minus X. When opening the bracket, we are going to multiply negative on both sides, whereby the negative side outside will affect the negative side inside, where it will turn to positive. We'll be able to get 34 minus 18 plus X. When we work on that, we'll be able to get 16 plus X. And after getting that, you transfer it to your Venn diagram. We're going to move to getting the number of S only. Since the total number of vehicles that had faulty steering system is equals to 40, we are going to say 40 minus, open bracket 7, minus x plus 6 minus 7. You cross the x in red colors because when you add negative with positive, you'll be left with nothing. Therefore, we are going to say our 40 minus open bracket 7 plus 6 minus x. Where we'll be able to get 40, open bracket 13 plus 13 minus x. When opening the bracket, the negative side outside will affect the middle sign, because when you multiply negative 1 with negative 1, where you'll be able to get positive. Therefore, we are going to get 40 minus 13 plus x, where we'll be able to get 27 plus x, and we transfer it on our Venn diagram. After getting the number of S only, we are going to move to the number of B only. Since the number of vehicles that had faulty bodywork is 29, we're going to say 29 minus open bracket 6 minus x plus 11 minus 6 minus x. We'll be able to get 29 minus open bracket 7 minus 17 minus x. When opening the bracket, you multiply the sign outside on both sides, where the negative outside will affect the side inside. When you multiply negative with negative, it returns to positive. So we're going to get 29 minus 17 plus x. We'll be able to get 12 plus x. We transfer it to our Venn diagram. That's how our Venn diagram look after representing the data. After that, we are going to get the value of x by adding all the numbers in the universal set. To make our calculation easy, we are going to take the number of t, which is 34, in the shaded region plus the numbers in the unshaded region. Well, we'll be able to get 34 plus 27 plus x plus 6 minus x plus 12 plus x plus 11 is equals to 94. After that, we collect like terms by saying 34 plus 27 plus 6 plus 12 plus 11 plus x minus x plus x is equals to 94. Where we'll be able to get 90 plus x is equals to 94. In this, we are going to collect like terms by saying 90 minus 90 plus x is equals to 90, 4 minus 90. We'll be able to get the value of x is equals to 4. After getting the value of x to be 4, we substitute the value of x equals to 4 to get the exact number of vehicles in each of the region on the Venn diagram. After substituting, after getting the value of x to be 4, therefore the number of b intersection t intersection s is equals to 4. And the number of 4 and the number and our task A that we should get the exact number of vehicle to be the exact number of vehicles had all the two defects. Therefore, the exact number of vehicles with all the vehicle defects is 4. After getting the value of x to be 4, you substitute the value of x on the Venn diagram, as I said before. And this is how our complete Venn diagram is going to look like. We move to task B, where it says, using evidence from the inspection finding, give a recommendation to the ministry concerning the establishment of another vehicle inspection center in the region. B, recommendation for establishment of another inspection center according to the guidelines. If you have to go back to our scenario, it says that according to the guideline of according to the ministry guideline, a new inspection center shall only be considered if less than a half of the inspected vehicles are found with only one defect. For that reason, you need to get the number of vehicles with only one defect by adding the number of T only with the number of S only and the number of B only. We'll be able to, we'll add 20 plus 13 plus, we'll add 20 plus 31 plus 16, and we'll be able to get 67 to be the number of vehicles with only one defect. So after that, you also need to get the number of, you also need to get half the number of the inspected vehicle by dividing the number of vehicle by 2. Since the number of inspected vehicle is 94, we're going to say 94 divided by 2. We'll be able to get 47 vehicles. If you are to take a good look on the number of vehicles with only one defect and with the number of vehicles and with the half number of vehicles inspected, 67 is greater than 47. Therefore, the recommendation, therefore the recommendation that the ministry shall not establish new inspection center because the number of vehicles with only one defect is 67, which is greater than a half of the inspected vehicle, which is 47 vehicle. Thanks.
Thank you so much for that wonderful presentation. That is from Moyo Secondary School. Any questions? In case you have any questions from the item that they have presented, kindly raise up your hand and then they can be able to respond. In case there is something you want more clarification on, this is the time for you to ask. Yeah, this is the best time for you to ask that particular question. Okay. I'm just waiting to see whether we have any questions. Okay. Okay. Okay, I think there are no questions. Thank you, Moyo, for the wonderful presentation. Okay, I'm going to ask Coach Goma to prepare. But allow me to say something about this particular item. Now, many times it may look as a simple item, but there are some areas or there are some things that sometimes make you students fail to get the maximum scores. Now, one of the things that you usually forget is missing the title. Dear students, whenever you are dealing with the data, please specify how is your data going to be presented. So we want to clearly see that you are going to use a Venn diagram. So this one sets the tone for someone to follow. It should be one of the opening statements up there on your work that shows what you are going to use. Now, sometimes some of us fail to translate the problem into set expressions. Sometimes some of you, when you find, let me say, either you fail to write those sets very, very well. Sometimes when you find it and you fail to know that one you're going to use what? An intersection. Where you find all, you find yourself that you are not able to write. Now you need to keep on reminding yourself, in case I find the word all, I find and, what kind of set notation do I need to write? Now, sometimes we have issues concerning equation setup. Now, when you look at the work that Moyo has presented, sometimes after some of you have extracted your work, let me say you have extracted the work, maybe E is equal to 15. Sometimes the way you present your equations here is not correct. So you need to make sure that your equations are well set. Now, number 4 is failing to define what you are going to use. Many times the unknowns are not going to be, they are not going to tell you that A is this, B is this, but we want to clearly see what is it that you are using for your Venn diagrams. Never assume that this is X, this is Y, without defining what you are using. Be very clear and say, let X equal to, or let X be this and the other, and let it be clearly seen. Then also we have what we call cluttered working. Sometimes your Venn diagrams are rough. Someone just draws something like this and it goes on. Make sure that your work is well labeled. The Venn diagrams are very clear. When someone looks at your work, then you can see that your work is very clean, very, very neat. Avoid just placing things anyhow. Avoid using a free hand. When you are coming up with those circles, never use a free hand. Get your pair of compasses and then come up with circles that are very good. And make sure that the size of the circles is the same. In other words, do not change the radius. After drawing the first circle, do not change the radius of that compass such that your circles are the same. Then please also pay attention to the language used in sets. Words such as only, when they say only means that that is the only area. Some of us, sometimes when they say, let me say this is A and this is B, sometimes they can say A and B only. Now you need to know that if they say A and B only, which part that this is the part of only. Otherwise, when you include this, it means that now that is beyond. Sometimes they can use the word neither. Sometimes they can use at least and complement. So you need to be very careful with the kind of wording such that you are very sure how to write. So whenever they use the word only means that the person belongs to one group only, not both. So when they say 20 learners play only football, so that means that those learners, even if you have your Venn diagram, let me say this is your Venn diagram, that this is football and this is what? netball. When they say 20 learners play football, we expect that this is the only area that you are going to put the word football. Because the moment you put this one means that these people also play football and netball. So be very, very careful when it comes to those words. Now, sometimes they're going to say neither nor. Now, neither means that that person does not belong to any of the sets. So that means that that person is not in any of the sets. They can tell you that maybe Patricia neither plays football nor netball. Then you need to know that if they say that that person does neither plays any, then it means that that person is going to be put out. Those are the people you are going to put where? Outside. When you look at the scenario we have been dealing with under set, they could also have asked you, like when you look at the last statement where they say that the engineers also established that 11 vehicles did not have any of the 3 defects under investigation. Now, that one was a bit direct. Next time they will tell you that the engineers also established that 11 vehicles were in good working conditions. That is the statement they use. Now, when you look at everything you had here inside, you note that all these were defects. So when they say that they were in good working conditions, then that means you need to think quickly that those are the people who like neither nor. So you have to pay attention to that. Next time they will give you, let me say they will put for you that the senior one, they like maybe cassava. Senior 2, they enjoy matoke. Senior 3, they enjoy maybe rice. And then they tell you, however, there are students who enjoy only maybe, let me say, drinks. Now you need to think that everything inside here is about food. That means that drinks is the odd man out. So you need to think. Sometimes they can even give you, whereby they have given you different drinks. They have given you soda. Let me say they have given you Mirinda. They have given you Coca-Cola. And they have given you here, let me say, Novida as the soda types. And then they ask you, but on the party, we had also beer. Now you need to think quickly that beer is not a soda. So that means that one, you are going to place it where? Outside. So you need always to quickly think on what, where, and what you are going to present in the different what? In the different regions. Okay. When they use the word at least, it means that that person belongs to one or more of the groups. They will tell you that 30 learners play at least one of the 2 games. When they say at least one of the 2 games, what does it mean? It means at least means greater than or equal to one of the games. That means that this child may play 1 game, may be playing 2 games or 3 games, meaning that when you are on your Venn diagram, you need to be very careful with that. In case this is our basketball, this is football, and this is netball. If they say at least one of the games, that means that this child can be playing 1, 2, or 3. So that means that you will have to put the child where? Here, or he can belong to here. He can be playing just 1 game. He can be playing only 2 games or 3 games. So that's when they use the word at least one of the games. Next time they can say at most 1. When they say at most 1, that means that this child may be playing just this is less than or equal to 1. This child may be playing 1 game or he does not play any game. Now you need to know what to place. That if they say at most 1 game, then you need to know that at most 1 game, I'll come here and say 1 game, this is 1 game, 1 game, 1 game. But when they say at most 1, there is a chance that the child plays 1 game or 0 or none of the games. So meaning that also you need to consider the ones that are outside the Venn diagram. So be careful with the words. Sometimes they can use the word both. That means when they say both, it means that those people belong to the 2 sets. They can say that you have these people and they say this is A and this is B. And they say that both A and B. Now you need to know that those ones belong to the 2. Next time they can say A and B only. Then you need to know that if they say A and B only, those people only belong where? Belong here. Sometimes they can use the word complement. Complement means that do those ones who are outside that. So when they say, let me say they say A complement, it means that anyone outside the A. In case I have a Venn diagram like this is my A and this is B. Anyone outside is what we call what? A complement. It does not belong to what? To A. Now, those are some of the words that they can use when it comes. Sometimes they can use twice as many. The number of students who play football is twice the number of those who play netball. Now here you need to be very careful. You have to first underline the number of students who play football. Then you say the number of students who play football is this. The number of students who play netball, then you say this is what? Netball. Then they have told that the number of football is twice the number. Then you are going to say that let the number of people who play netball be what? X. Then you can say that the number of people who play football is twice the number of people who play netball. So this is how you write it in set notation. Like I said that always be very careful. You can even first do it manually. You say this is football and this is netball. If this number of people who play football is twice, meaning that it is more than, then you know that if this is 1, this is going to be 2. If this is 2, this is going to be what? Is going to be 4. That means that you are going to be multiplying. So that's why for the now, so you notice that to get football, I have to multiply 2 times the number of people who play netball. So now those are some of the words that you are going to find them. Next time they can use half as many. Then you need to come and say that the number of students who play netball, you come and first write that one. Netball is half. Then you put half as many as those who play football. Then you say this is football. So that means that the number of those is equal to half those who play football. So in case you meet such statements, that's how you can go on and write those statements. So you have to be very careful when they use words such as twice, half, and the rest of that. And what are some of those scoring areas when it comes to sets? They will give you a score for the title. Labeling of your sets with letters or names, that one is also a score. Inserting the data correctly in sets, like the first thing always you do, make sure that your data is well inserted, that this is A4, this is maybe C. Insert your data very what? Very well. Let your data be there in when it has the unknowns. Then after you can have another set where you have no unknowns. Then clearly show your calculations. Even if you are just finding this, please show how you are getting this value. Some of you are used to just doing this. Someone will come and say, this is just, and then you just get the answer and you go, sure, and clearly say, now finding F only, and then come up with your working. Now, those are a few things you need to know when it comes to Venn diagrams. I'm seeing a hand. I'm seeing a hand up. Teacher David. Teacher David. Okay. Could this be Coach Goma? Yes. Kindly. You speak, dear students. Okay. Coach Goma. Okay. I'm saying Coach Goma. Coach Goma, unmute.
Ready to go. Hello.
Hello.
We are ready to go, eh?
Okay. Kindly let's start.
Yeah, I'm there. So the first one will be
Good afternoon.
Yes. Good afternoon to you.
I'm
Kindly.
going to take item 18. The scenario goes like this. Item 18, under construct, geometry and measures. A school management committee planned to renovate one of its classrooms in preparation for the new academic year. The classroom measures 8 meters long, 6 meters wide, and 0.5 meters high. The classroom has one doorway measuring 2.1 meter by 1.2 meter and 4 glass windows, each measuring 1.5 meter by 1.2 meter. As part of the renovation, the committee intends to repaint the classroom walls to improve the appearance of the learning environment. The paint was applied in a cylindrical bucket of internal radius 10 centimeter and height 30 centimeter. Filled completely with paint. It is known that 1 liter of paint covers 10 meters square. The committee also plans to cover the entire classroom floor with square ceramic tiles measuring 25 centimeters. To cater for breakages and wastage during installation, the contractor recommended purchasing an additional 5% of the required tiles. 2 suppliers submitted quotations for supplying the tiles. According to the quotations received, supplier A would supply tiles in boxes containing 20 tiles at a cost of 45,000 shillings per box, while supplier B would supply tiles in boxes containing 30 tiles at a cost of 68,000 shillings per box. The school management committee wishes to minimize expenditure while ensuring that the renovation work is completed successfully. Task A. Support the school management committee in determining whether the paint supplied will be adequate for the painting work. B. Advise the committee on the most suitable supplier for completing the floor renovation. Give reasons for your answer. So my friend will take the responses. Okay, good afternoon, members. Call me Acha Flavia, a candidate from Martina Secondary School. So the item was taken under the theme geometry and measure. And from here, they are in need of painting the classroom. So we have to first come up with the sketch of the classroom, and the sketch is in cubic form. So from here, we are going to sketch the wall of the classroom. So here is the sketch of the classroom wall.
Cannot see where.
So from here, this is the sketch of the classroom as it was read in the scenario. And they say that the classroom is having the length of 8 meters. Then the weight of the classroom is 6 meters, and its height is 0.5 meters. This is our classroom, and it is having a doorway. That is the open where you can enter in the classroom.
Coach Gomba, may I ask you that we improve the sketch to show clearly that 8 is bigger than 6, such that we depict the real picture. Dear students, when you are making the sketch, ensure that the dimensions you are putting depict the real what? The real picture. Okay, thank you.
Yeah, this is the state of the classroom. As we are seeing now from here, the length of the classroom is 8 meters, and its width is 6 meters, and it's having a height of 0.5 meters. So from here, we need to find the total area of the classroom, and from the total area of the classroom, we are going to find the area of the doorway plus the area of the 4 windows. After finding the areas of the doorway, we are going to add it plus the area of the. We are going to add it with the area of the 4 windows, and we are going to find the area of the classroom that will be pasted. So the area we are going to find, as we are saying, a cubic wall is having 4 surfaces, 2 longer surfaces, that is from here and here, and it's having 2 shorter surfaces, that is from here and here. So from the area will be equal to 2 into bracket, this will be the length and the width, then plus 2 into bracket, no, this will be the height of the classroom, and this one will be the width of the classroom times the height. So area will be equal to 2 into bracket, this will be 8 times 3.5, this will be in meters, plus 2 into bracket, 6 times 3.5, and it's in meters. So our area will be equal. This will be 2 into bracket, 8 times 3.5, we are going to get 28 into bracket, then plus these 2 plus, you will open the bracket, then you multiply 6 times 3.5, which we're going to get 21 meters. So from here, we are going to multiply this 2 times 28. We are going to get 56 meters plus this 2 times 21, which we are getting 42 meters. And we are going to sum up this 56 meters plus 42, bringing us 98 meters square. And it is the area of the classroom wall. So from here, in the scenario, we were given that the area is having a doorway. The wall of the classroom is having a doorway. So from here, we are going to find the area of the doorway. And this will be the state of our doorway.
Right.
So from this scenario, they were telling us that the doorway is having a height of 2.1 meter and the width is 1.2 meter. So from here, we are going to trace the height of the doorway as the length. Because in every room, the height of the door is much bigger than the width of the door. So from here, it was given that this height is 2.1 meter, and the width of the doorway was given as 1.2 meters. So area is equal to length times width. So our area is equal to 2.1 meters times 1.2 meters. And the area will be equal to 2.5 meters square. And this is the area of the doorway. And this scenario was given that the doorway was only 1. So we are not going to multiply the area because the doorway is only 1 in that classroom. Then after finding the area of the doorway, we are going to find the area of the windows of the classroom.
Find one window. Right.
Here it was given that the window, and from here the sketch of the window would look like this. It was given that the window is having an height of 1.5 meters, and the width of the window it was given as 1.2 meters. And there were 4 windows in the classroom. So we are going to find the areas of the all 4 windows. Then from here, area equal times the width. From here, we are going to create the height of window has our length. So in the scenario, the gate has 4 windows. So the area of B equal area is equal to 4. Then into bracket this 1.5 meters times 1.2 meters. Then the area of B equals to 4 into bracket. We are going to multiply this 1.5 meters times 1.2, giving us 1.8 meters. So from here to get the area, this is as the area of only one window. So to get the area of the all 4 windows, we are going to multiply this area times 4. Then we are going to multiply 4 times 1 times 1.8, giving us 7.2 meters square. This is the area. This is the area of the window of the classroom. Then now after getting the area of the doorway plus the area of the window, we are going to get the area of the classroom that will be painted. So area of here we are going to that the area of the class was 90, so we are going to make 98 meters squared. And we are going to subtract the area of the doorways and the area of the windows to find out the area that will be painted.
Excuse me, coach.
The area of the doorway was 2.5 meters square.
Coach.
Plus the area of the windows that was 7.2 meters square. Then will be 98 meters square minus. We are going to add this 2.5 meters square plus 7.2 meters square, giving us 9.72 meters square. And the area of the classroom that will be painted will be equal to 88.28 meters square. This will be the area of the classroom that they are going to paint. And in the scenario, the girl has that. My friend first has to do this.
Excuse me, coach, before you leave. A minute.
The pen.
Coach, teacher, a minute. Coach, are you able to hear us?
We can hear you.
Okay, yes. I want her to first go back here on the middle screen, this side, where she had 2.5. 2.5. Are you seeing 2.5? No, yes, there is a 2 missing there. 2.52. Oh, 2.52. Not, oh, 2.52. Okay. And then also on the previous one. Thank you. But the rest are okay. The rest are okay.
Given that the cylindrical basket is having a radius of 10 centimeters, and the height of the basket it was given that it is 30 centimeters. So from here we are going to find the value of the basket. So this is the formula of getting the value of any cylinder. So from here, value is equal to attack times 22 out of 7, which is our size, times the radius, which is 10 centimeters in square, times the height, which is 30 centimeters. So value is equal to so the volume of the basket will be 3,142.85 cubic centimeters. So this is the volume of paint contained in the basket. And we have to convert this value to liter because we are going to be painting using liters. Equal to 1 liter. If 1,000 cubic centimeter is equal to 1 liter. Now, if 1 cubic centimeter will be equal to 1 divided by this 1,000 liters. And from here, we find out that the volume of the bucket was 3,142.85 cubic centimeters. Which would be equal to this one divided by 1,000 times this 3,142.85 cubic centimeters. Find out the liter that is contained in the bucket. Giving us 3.14 liters. So this is the liter of paint that is contained in the bucket.
Not enough to move.
At Montessori, they were telling us that 1 liter of paint is painting 10 meters square, the class. So from here, we are going to get now the liters of paint required to paint the whole class. It was given clearly in the slide that of paint is covering 10 meters square. And we found out that the area of the class that is painted is equal to 88.2 paint meters square. That 1 liter is equal to 10 meters square. Now, if 88.28 meters square, we're going to find the number of liters that is required. So we can use any letter. Now, x. So I'm going to multiply this x times 10, and we're going to get 10x is equal to this 1 times 88.28 meters square. And we're going to divide both sides by 10 to find the value of x. Giving us 8.82. Now we are going to write 823 liters. So the wall of the classroom that will be painted is requiring 8.83 liters of paint. But the bucket is containing only 3.1 liter, and our part A of the scenario is requiring us to find out the number. It's requiring us to find out if the liter of paint contained in the bucket enough for painting the whole class. So from here we have already compared that this bucket is containing only 3.14 liters of paint, and the classroom is requiring 8.83 liters. So the paint supplied in the bucket will be inadequate for painting the whole classroom. So we are going to start the form picture. Here is our form. The cylindrical packet of a paint in 1.4 liters, which will not be enough for painting the whole class. Therefore, the community should buy more paint for painting the whole classroom.
Okay, as she's writing the conclusion, Teacher David, Tops High School, you can unmute. You may ask. Oh, I'm failing. PC, unmute.
Good evening, sir.
Yes, good evening.
Yes, we are asking, we have seen this side on the volume, and we are seeing that it is written in meters squared. Yes, and it's supposed to be cubed. Yes.
Okay, thank you. Top Times High School, Chengera. Oh, okay, I'm failing to get. Popo.
Yeah. So so questioning myself about the formula used to get the volume of the cylinder, because I think maybe, as we were taught, the formula for finding the volume of a cylinder is pi radius.
The right formula. Right formula. Maybe the teacher would teach us, you just mislead you.
Okay. Okay, I'm going to, Coach, allow me to first make some clarification on that. Allow me to first make some clarification on that. Let me first share my screen briefly about the cylinder. So let me share my screen briefly. I'm going to share my screen briefly about that. And then we clear the air. Now, when you are finding the volume is always given by base area times the height. That's how you get the volume. So allow me to share my screen. Hope my screen is there. Now, when you look at my screen, I'm showing you that there are two things that you need to know. That whenever I'm talking about volume, I'm always looking at the base area, and then I look at the height of that particular figure. Now, when you look at the cylinder, let me say this is our cylinder that we have, something like this. This is our cylinder. When you look at the cylinder that we have, in case this is the cylinder, you notice that this is our radius, and this is the height of the cylinder. But when you look at the shape we have here, this shape here is a circle. And when I'm finding the base area, even if I have the base here, still this is a circle. Now, to get the area of a circle is always given by pi r squared. Meaning that when I'm getting the volume of a cylinder, I'll have my base area, which is pi r squared, then times the height. So that is how we get the base area. However, From this cylinder that I have, I can go on and obtain a cone. When you look at the inside here, you can note that inside here, in my cylinder, I can have, this is my first cone. Inside this cylinder, I can have another cone inside. When you look at this one can be my second cone, or I can do it like this. I can have another cone like that. One can be my cone. So inside the cylinder, I have 1, 2, 3. So inside the cylinder, I have 3 cones in it there. Meaning that if I'm to get the volume of this cone, volume of the cone, since there are 3 cylinders, to get just one, it's going to be 1 out of the 3, but of pi r squared height. That one cone out of the 3 of the total volume of the cylinder. Now this formula is for the volume of the cone. So whenever you have 1 out of 3, then that one means that you are finding for the cone. Where does the 3 come from? The 3 comes from because inside our cylinder we have 3 cones that can be obtained. In other words, if you have one cylinder and you want to fill this cylinder, what does it mean? For you to be able to fill the cylinder, you will need 3 cones. Once you have 3 cones and you pour them inside the cylinder, you'll find that that cylinder is going to be full. That is when it comes to a cylinder. But still, allow me also to bring this one to your attention. Now, the next one I can look at can be the pyramid. Now, a pyramid comes from a cuboid. When you look at the cuboid here, you notice that inside the cuboid you can form 1, you can form 2, you can form 3 pyramids. But when you look at the volume of the cuboid, this one is always our height. This one can be our width, and this one is always our length. So like we have said that volume is always given by base area times our height. Now the base area for this is this one here, which can be given by length times width. However, our height is h, so meaning that the volume of a cuboid is given by length times width times height. Now, when it comes to a rectangular pyramid and I'm finding the volume, since there are 3 pyramids inside, to just get the volume of one, I'll say 1 out of the 3 of the volume of the cuboid, which is L times length times the width. So now that is how you come up with that particular formula. So whenever you find that you have a third is an indicator that that particular figure is originating from somewhere. Okay. Hope we're on the same page, coach. Coaching? Our discussant?
So this be the volume of power of that and from here, of the paint contained in the bucket. So from here, I guess you're going to put down 10,420.5 cubic centimeter. B equals to this 9,428.57 divided by 1,000. This will be the liters of paint content in the bucket. Here, the class. Now, if 1 liter of paint is covering 10 liters square of the classroom, now we have to get for the class from the liter of paint that is being to paint the whole class that is having an area of 88.2. But the area of the class we painted is 88.2 meters square. 0.28 meters square. So we can put here any unknown, and we're going to multiply this x times 10, giving us 10x, which is equal to 88.28 meters square. And we're going to divide both sides by 10. So giving us 8.82 liters. Therefore, 8.82 liters of paint will be required for painting the whole class. And from there, we get the liters of paint contained in the bucket as 9.42 liters. So from here, we are clearly seeing that this paint will be enough for painting the whole classroom. And we are going to come up with a conclusion that be our conclusion. So my friend will take you in part B of the scenario. So the part was that we should advise the committee of the most suitable in the scenario. They gave us that the committee also plan to cover the entire classroom floor with 25 centimeters. To cater for breakages and wedges during installation, the contractor recommended purchasing an additional 5% of the required time. Two suppliers submitted quotation for supplying the gas. According to the quotation receipt, supplier A in boxes containing 20 liters at a cost of 45,000 shillings per hour, while supplier B would supply tanks in boxes containing 30 liters, no, 30 tanks at a cost of 68,000 shillings per hour. The school management committee wishes to minimize expenditure while ensuring that the renovation work is completed successfully. So the task is advise the committee on the most suitable supplier for completing the renovation. Give reasons for your answer. So members, I'm going to take you through part B of the scenarios, which is talking about installation of the tank in the classroom. So we shall first come up with the shape of the classroom floor, which is in a rectangle form.
No.
So from here, we can draw the floor of the classroom. And the same from here, the floor of the classroom is measuring 8 meters, which is the length, and 6 meters, which is the width. So after extracting the floor of the classroom, we are going to find its area. Being it's a rectangular floor, we shall generate it from this formula, which says area is equal to length times width. So our length is 8 meters times the width, which is 6 meters. We shall square it. So from here, we are going to obtain the area of the classroom, of the floor of the classroom, let's be 48 meters. After getting the area of the classroom floor, we shall continue from here to get the area of the single side of the side, which will be installed in the classroom. This square, which is set, it's a square. So the square is measuring, the times is measuring 25 centimeters. So from here, we are going to get the area of thing of this size. So as all of us we know that area of a square is given by sides and sides by sides. So our area from here is 25 centimeter by 25 centimeter. So we shall get our area to be 625 centimeters squared. Since we have got area of the classroom, so 40 meters squared, and the area of the single side is 625 centimeters squared, and the area of these sides is in a different, the unit is different from the area of the classroom floor. So we shall convert the area of this single side, which is in centimeter, to meters. So here we shall say 100 centimeters is the same as 1 meter. And then what about 100? 100 centimeters is the same as 1 meter square. So 100 square can be able to get 10,000 centimeters. It is equivalent to 1 meter. Centimeter square is 1 meter square. So from here, we shall say 1 centimeter square is the same as 1 out of 10,000. Since now 1 centimeter square is the same as 1 out of 1,000. This is meter square. So from here, in order for us to get this 625 centimeters square into meter, we shall say 1 cubic centimeter is the same as 1 out of 10,000 times 625. So shall come up with this 1 times 625, we shall get 625 over this 10,000. This one will be 2 meters. So after pressing this one on the calculator, shall come up with area of 1 single cell will be 0.06. So this is the area of 1 single tile. It will be a area of 1 single tiles. So here, now we have the area of the number of tiles which is required in this classroom by dividing area of the classroom floor over area of 1 single tile. Yes, we now need the following information. Area of the classroom floor number of tiles, we shall say area of classroom floor over area single tile. So that's our area to be 48 meters squared out of 0.0625 meters squared. So this meter squared and this one will cancel. The remaining 48 out of 0.6 and we shall get 768 tiles. So here the part of the scenario is telling us to set up for breakages and pieces during installation. The constructor recommended percentage and additional 5% of the required time. So from here we are going to get 5% of the required times. So from here, we're saying we have got the number of times that the committee purchased for installation being 768 times. And here they're also saying to get the operations during installation, they need 5 additional percentages of the required times. So we shall additional 9. They say they need 5% of the additional time. 5%. So we shall add this 5% out of the total percentage, which is 100, times the number of times that is needed for the floor installation. So we're going to get the additional times as being 34, 38.4, of which we shall, there is no 0.4 times, of which we shall run it as well to give us 39 times. For us to get the total time that is required for the installation, we shall add this. We shall add this. So we shall add these 768 tiles needed for the installation. This is 768 plus the additional tiles to set up the space. 39. This is a total 807. So the number of times needed for the construct for the installation and the flow is 8. So we have to now have that no supplier submitted return for supplying the tile. According to the quotation received, supplier A would supply tiles in boxes containing 20 tiles at a cost of 45,000 shillings per box. When supplier being supplying tiles in boxes containing 30 tiles at a cost of 68,000 shillings above. So from here, start with supplier A. They're saying supplier A would supply 20 tiles. 20 tiles at a cost of 45,000 shillings above. So from here, for us to get the total money required for buying these tiles, we shall first need to get the number of boxes needed. So we are going to say the number of boxes, this total number of tiles needed, of number of tiles contained in the box, which is here our number, the number of boxes we shall have 807 out of 20, leaving us 21 boxes from supplier A. Now, total money that spent buying the time supplier is that multiply this number of boxes and the cost of 20 times per box, which is 40 times. So here we're going to multiply each by we're going to add 1 and 4 we have 5. So we shall go to the supplier B. Yes, that's 5. B. 8,000. So we shall here and first get the number of boxes needed. So the number of boxes
Are we failing to get a coach? As coach gets back, sludge.
8.4. Yet
Come again.
Why is the answer 38 point? Why is the answer 39? Yes, 38.4 rounds off.
Oh, now the answer of 30, you have said 38.4.
Yes, sir.
Okay, that was for which one? Come again. The 38 was for?
38.4.
Yes?
38.4 liters.
Like 38.4, like it was for what?
Part B.
Part B. Like what were you finding? The area of?
The liters.
Yes?
Liters.
Oh, like the answer was 38.4.
Yes. No, it was 38, not 39.
Oh, now why they wrote us 39? Like when you are buying things, they cannot sell to you something like 38.4. So they cannot give you that 0.4. So when you meet such, they round off or they approximate to the next value. When you look
Yes.
at the tiles, also I think you might have noticed on the tiles. On the tiles where she obtained 40.35, because they can't give you a 0.35 tile, they would rather give you a full one, then you remove the part for you want.
Okay. Okay, thank you.
Okay. St. Paul, Anak, unmute. Okay, I'm failing to get St. Paul. User, unmute.
Good afternoon, sir. I
Good
just wanted to
afternoon.
ask a question regarding when they did section A, when they were carrying out the area, they only use length times width and width times height. Why didn't they also, to get the surface area, why didn't they also use length times height? Why did they only use length times width into brackets, like out brackets 2 plus length times height out brackets 2, but they didn't put the third like thing for getting the surface area? That part has confused me up to now, yet I've read the question 2-3 times and I failed to
Oh,
interpret
is
that
my
part.
screen on?
Yeah.
Are you seeing my
No, not
screen?
yet. Not yet. Yeah, now I can
It
see.
is. Now, what happens is like when you have let me say, this is my sketch. Are you seeing
Yes.
my sketch?
Yes.
Now, when you are painting or when you are going to do any kind of painting, mainly when we are painting, down on the floor, here, you have the tiles. So meaning you are not going to paint it. True? Up
Yes,
this
true.
side, you have the ceiling.
Yes.
So you are not also going to paint it. So you'll find that you're
Yes.
going to paint these opposite walls and these ones here.
Yes.
So that means that if I use,
Okay.
okay, is it clear now?
Yeah, I have got it now. Thank you, sir.
Okay. Okay. Any questions? Oh, yes. People were still asking about the tiles is that we cannot have 40.39 tiles. So for that one, you round off to the nearest whole number, and that is under. Okay. Okay. Let me hope that is okay. I want to just check whether Goma they are back. Oh, unfortunately, they are not yet back. They are not yet back. Okay, but since they are not yet back, I'll ask you to complete that particular item. The only thing that you needed to do is that you had to look at the second supplier. And when you look at the supplier for the second one, when you look at him, you'd have noticed that for him, he needed 27 boxes. That is for the supplier B. So you had to go on and look at the second supplier and then obtain the number of boxes that supplier B can offer, and then you compare accordingly. So when you look at the second supplier here, I would expect that you're going to come and say our supplier B, and then you get the total area for that particular supply of the area divide by the number and then you'll end up with 27 boxes. That is for the second supply, and then you can compare the amount and then you compare the two suppliers. That's what you had to do for that particular one. Now, from there, I want us that always, I want you to relate to real life. What we have been looking at, when you look at my screen, this is what we have been looking at. Some of you you may not have noticed, but when we talk about the cylindrical buckets, this is what we are referring to. When you look at these buckets here, you'll find some buckets that carry 20 liters. You may have seen these buckets at home, in markets, when people are using them. This is where we put our paint. Sometimes they manufacture in this. These ones, sometimes they have only 4 liters. We have those ones of 10 liters and the rest of that. Now, when you look at this is a cylinder. This is a cylinder that we are looking out for. So whenever you read the item, whenever you receive this particular item, kindly go on and ask yourself, how does it look like in real life? Then it will give you a good picture on how to start. So I know some of you may have even confused it with frustrams and the rest of that, but you need to have it at the back of the mind that if it is paint, how do those buckets look like? So this is how the buckets look like. Okay, so can we have, there is a school that they prepared. I think we have failed to get the school back, but we are going to move on. But I'm going to request the teachers on the call to take some photos of the children who are seated in the main halls, and then you can share with us on the group. Okay, we have a school. Okay. Okay. I don't know whether Sesame girls are ready. Then we had a school that wanted to use the whiteboard. I don't know whether they are ready. Kindly raise up your hand and then you take us through. Top times. I don't know whether you are still on. Top times. Kindly unmute. Top times. Top times. I don't.
Mbabuze list of the items.
The host is not
Top times. Top times. What are you going to use? Choose.
We are on.
Yes, top times you can share your screen. Okay. I think we are failing to get top times. Top times I'm failing to get you. Top times. Oh, Teacher David, do you have a question? I'm saying your microphone is unmute. I don't know that is a question. Okay. I think I'll fail to get top times. Top times I'll fail to get you. So we are going to go. I don't know whether. Okay, I failed to get top times. I think top times, are you coming on?
Yes, are you getting us? Are we
Yes,
on?
we can hear you. We can hear you.
There was a student who was asking for the list of items that have not been done.
Oh, I sent them in the chat. But we had item 17. It was not yet done. We had the last item 20
number 10
also.
done? Excuse me?
Yes, please.
Was number 10 done?
Number
Number 10.
10. Yes, it was done. Number 10.
Oh, she wanted to do that number.
Number 10.
Okay, which free number so that we can prepare?
Okay, number 20 would have been one of them. Okay. Okay. I'm going to share my screen. I'm going to share my screen briefly, and then we shall run through the last one of those numbers together. We are going to run through that number together. Yes, allow me to share my screen because no school has done it yet. Yet we could do it together. So, allow me to share my screen. So we are going to go through this last item together. When you read through the item, dear students, always go on underlining the mathematical concepts. So they told that a school football team was preparing for an inter-school competition. During a training session, the coach went on to mark the points. So the coach went on to mark this point, marked this point, and this point on a coordinate grid. To improve the movement patterns during the second training session, the coach repositioned the cones by rotating the jogging area through a positive quarter turn about 1-1. To accommodate addition players, during the final training session, the coach doubled the distance of all corners of the reposition training area from the origin, creating a larger training ground. The school field has a running track boundary modeled by the line this. The coach wanted to ensure that the enlarged training area remained within the designated training zone task helped the coach to represent the original training area and the adjusted training areas on a suitable. Now, when you look at this item calls in for the knowledge. Number one, we are looking at, do you know how to plot coordinates? That is the first thing. Do you know how to plot coordinates? That is one of the things that we are looking out for. Number two, there is what we call transformations. That when you talk about rotating the jogging area, you know that here you are talking about rotation. And which angle? It is a positive quarter turn. And about what point? About 1, 1. Now, when you read through here, they have brought in the element of enlargement. That is senior to work, senior to work. From there, they went on and brought in the area. You drawing the line, knowing how to draw the line, what we call the boundary line. Now, those are the things we are going to look out for. Now, when I come on my graph, let me say, this is my graph that I do have. What am I going to do? I'm going to draw my plane. So I'm going to come here and I say, this is my Cartesian plane. I'm going to draw. I'll come here. I do like that. Then, now since your graph is showing the training ground, I can put here a graph showing the training, showing the training area. Then, whenever you are drawing your graph, never forget to label it. So make sure that you always label that this is my y-axis. This axis here is my x-axis. Then from there, the next thing you are going to do is started from 0. This is 1, this is 2, 3, 4, and 5. This is -1, -2, -3, -4. Demarcate 1, 2, 3. This is -1, -2, -3, -4. Then we are going to plot. When you check our first point, -2, -2. When you check the second point was 1, -2. When you check the third point was 1 and 3. And point D was -2, 3. So you are going to plot. I start with A. A is -2, which is here, and -2. So I mark that point and I say this is point A. The next one is 1 and -2. 1 is here and -2 here. I label and I say this is B. The next one is C, which is 1 and 3, which is a point here. Then the next one is D, which is -2 and 3. So this is our point C and this is our point D. Now, after drawing the original area, we are going to go on and join it. So I'm going to come here. I get my ruler and I join. That I've joined this point. From here, I can join here. Then from here, I join in here. From here, I join there. Now that is my original training ground. So that's how you represent your original training ground. Now, after obtaining your original training ground, they went on and told that to improve the movement patterns, the second training session, the coach went on to reposition by rotating the jogging area through a positive quarter turn. Now, come and show. So I'm going to come here and I say now, rotation of the original playground. So I'm going to come, what was the rotation was a positive quarter turn. So now here I will say positive quarter turn. So it means 1 out of 4. When they talk about positive quarter, a turn means 360. Clearly show. And then I'll come and I say, when I have 360 divided by 4, these are 90 degrees. That means that your angle of rotation that you are going to rotate through is going to be 90 degrees. However, they went on and said that the area was rotated about a point. Now here is what we call the center of rotation. The center of rotation was given by 1 and 1. What are you going to do? You are going to go on your graph again and take note of 1, 1. So when I come here on my graph, I'm going to come here and I take note of 1, 1. So I'm going to say 1 and 1 is a point here. And this is my center of rotation. Now, after getting my center, since this is a positive quarter turn, it means that I'm going to be turning in the anti-clockwise direction. So what am I going to do? Now, always what you do, you are going to rotate all the points. So the first point I can rotate, I'm going to come here. Feel free, when you are rotating, you can use the dashes. So allow me to use another color. Let me use this color. So I'm going to rotate. The first one I'm going to rotate is here. This is my point. Now, when I'm rotating, since I'm rotating in the positive quarter turn, I'm going to come here. I place my protractor like that. Now, when I'm rotating this, what do you need to take note of? You need to take note of that number 1, your protractor must be at this point. That is number 1. Then number 2 is that you need to know that if this is the center of the protractor, then you are going to place it like that. So that is how you are going to place your protractor. When it comes, let me say now I'm rotating this second point. What am I going to do? I'm going to come, I first join here, 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 like that. Then after, get your protractor. When I'm rotating, I'm going to place my protractor. But now here, I'll place my protractor like this. I hope now that is very clear. When I place my protractor, this one should be the center of the protractor, then I count off 90 degrees. So I'll come and I say, where is the 90 degrees? That 90 degrees is going to be, let me say, is going to be somewhere here. Now, after taking note of that point, what you do, get your protractor off, and then draw a line. You can use the dotted line that my 90 is somewhere here. After doing so, you know that here I've rotated the 90 degrees. Then this distance you have here and here, in case this is, let me say, this is 5. Also here, you're going to measure off 5. So when you measure off 5, let me say it lands here. That's where you're going to put your D prime. So after that, you are going to go to the next one. Let me remove it. Let me remove now this. Now, even for this one, when you are placing your protractor, since you are supposed to turn 90, you place it like that. So your protractor, since you are turning, it will be like this. So you turn the 90 degrees here. So 90 degrees for such, they will be somewhere here. And you'll find that here, your thing will land somewhere here. So your point C prime is going to be here. The same thing, first join A, your center here. After that, place your protractor because you are turning and clockwise. So what are you going to do? You are going to place your protractor like this. Then measure off 90 degrees. Let me say they land here. Then remove it and then draw a line. Measure this distance here and then the distance here. Do the same to B. Place your protractor, measure off the 90 degrees. Now for this B, you'll place it like this, measure off the 90 degrees, and then you go on and you place. Now that's how you deal with this. But this one is more practical. You need to do it in a practical form. But now that is how you are going to do it. What am I calling out for? Now for this one, you do it as a class. You can do it as an individual and then take you to your teacher to do it. So at the end of the day, you are going to find yourself that you have maybe something like this that has been rotated inside. After it being rotated, remember you're going to enlarge it. Now to enlarge it, since they told us that it is with respect to the origin, what always you do, get the origin. Now you need to remember that whenever the scale factor is positive, that means that the object and the image are going to be on the same side. If the scale factor is negative, then you allow me to repeat. I repeat. If the scale factor is positive, what does it mean? It means that your object and image are going to be on the same side. If the scale factor is negative, it means that the object and the image are going to be on the opposite side. So that one. And now here, when you look at it, they told that the coach doubled the distances. That is an indicator that the scale factor was 2. So here, it means that you are going now to double them by 2. So your scale factor here is going to be 2. So that's how you can briefly approach this particular question. Then from here, you need to know how to read off the coordinates and how to extract them from here. Okay, so do we have any questions? I've not completed everything because here you need to do it practical as a school. Yes, kindly you can raise up the hand in case your question is about this and maybe there is something you need more clarification on. Okay, I think it is okay. So do it, dear students, and then you can share with us what you have come up with. Feel free to share with us, and then we shall be able to guide you. So I want to maybe emphasize once again a few things as we come to the end of the session. Number one, I want when you are dealing with the statistics, ensure that you write your title. Never forget the title. Label the presentation columns. When we talk about columns, I want you that when you are extracting data, the first 2 columns that you will always have must correspond to the data you have. In case the question is talking about hours, this one should be hours. In case they're talking about number of students, this should be number of students. So the first 2 columns in your data, in your frequency distribution table, should match with what is within our scenario. Please make sure you practice how to come up with an ogive, how to come up with a histogram, how to come up with scatter graphs, how to come up with graphs such as the frequency polygon. All those things are what? All those things are examinable. So you need to know a frequency distribution, a frequency polygon. Oh, Moyo. Okay, Moyo has the graph. Moyo, could you share your screen? I think we can use Moyo. Moyo, if you have that graph, kindly share such that people can look at it as I pick a hand from Charlene. Charlene Secondary.
Yes, sir.
Yes, sir.
Yes.
Yes.
Some requesting you highlight for me some.
Some requesting you highlight for me some. Some requesting you highlight for me
There is
Yes,
a
sir,
lot
I'm
of
requesting
echo.
you.
Yes.
Yes, hello, sir. Are you
Yes,
seated here?
continue.
Yes, sir. I'm like requesting you highlight for me something on rotation and reflection.
Okay. Moyo, okay, I'm going to do
Hello.
so. Moyo, are you sharing your graph? I want to know whether Moyo is sharing the
Sir, I'm
graph.
saying.
Yes, yes, sir.
Okay.
We are sharing.
Sir, I'm like requesting you highlight for me something on reflection.
Okay. Hope, are you able to see the graph? Okay, Moyo, can you say something? Let us first give the opportunity to Moyo to present that number.
Can you say something? Let us give the opportunity to Moyo to present that number. Can you say something?
Okay, sir. This is Joradona from Moyo Senior Secondary School. This is our graph. For sure, this work need a practical work. In order to make the students to understand it well.
It is okay. Maybe you could do show us maybe part B.
Part B.
Such that also members can look at yes, okay. So members, you'll check out that those are the coordinates you have. Okay, Moyo, continue.
Talk about it.
Okay, after plotting and the final training graph, that the image of A after the enlargement, the points for A is going to be 8, -4. And for B will be 8, +2. And C will be -2, 2. D will be -2, -4. And also they require you for the size of the training ground. And if we are to go back to our graph, after the enlargement, you look on the picture of on the graph of the enlarged area, the final ground, that to say. You count the number of the small squares seen along, which is going to be our length. If you are to count it, they are 10 in number. And you turn to the width. If you are to count it, it is 6 in number. From there, since they are requesting for the size of the final training ground, we're going to say area is equals to length times width, where we are going to say 10 times 6 square unit. Our final answer is going to be 60 square units. Since and part C was asking us whether the final training area remains within the designated training zone. And if you are to check in our graph, and the designated zone is y is equals to -5. From 0 on the line y is equals to 0, if you are to check, negative y is equals to -5 is down here. And the final training area after enlargement ends at y is equals to 4. That means -4. That means the final training area lies above the school boundary line, which is zy is equals to -5. The training area remained within the designated training zone. Thanks.
Okay, thank you. We have some questions. Elvis, Elvis,
We are requesting that you highlight for us the scale factor.
okay. Moyo, can you say something about the scale factor?
I think we can put our input on that. When you go back to the scenario, okay, to improve the movement pattern during the second training, they are saying that the coach repositions the cones by rotating the jogging area through positive quarter turn. So that one was basically for getting the second image after a rotation through positive quarter turn. Now, to accommodate additional players during the final training session, the coach doubled the distance of all the corners of the repositioned training area. So doubling means the position of the second training ground after rotation of positive quarter turn, each of them will be doubled using the scale factor of 2, because when it says doubled, that is already scale factor 2. And it had already given the center of enlargement at 0.00. So which means since the scale factor is 2, that is already a positive enlargement. And as Mr. Kazib already put it clear, positive enlargement means both the object and image will be on the same side of the center of enlargement. So what we shall do is, for example, where we already mark our center of enlargement at 0.00, for instance, if we want to get the position of point A after being enlarged using scale factor 2, what you do is you first get the distance between the center of enlargement and the point A, and then you measure that distance 2 times on the positive direction, starting from the center of enlargement. You don't start measuring it from point A. You measure that distance 2 times from the center of enlargement, then it will give you the second image or the final image of point A. So you also do that same procedure for all the points for point B, C, and D. So that's when you'll be able to come up with the final training ground after enlargement using scale factor 2. I think the most important point to consider there is when you are enlarging using a particular scale factor, you start measuring that distance, whether the scale factor is 2, 3, or 4, and so on. That distance should start measuring from the center of enlargement, not from that point which you're actually enlarging. I think that is one of the points as teachers, sometimes we need to emphasize so much for the students. Thank you.
Okay, wow. Thank you so much, teacher, and thank you so much, Moyo, for this technology and for the great presentation. I saw Charlene. I think I'm still seeing your hand up. Kindly unmute.
Yes, sir.
Yes, yes, go on.
Are you getting me, sir?
Yes, we are getting you.
Yes, go on. Yes, sir. I'm requesting you highlight for me some key areas of reflection. Yes, we are getting you.
Okay.
Yes, sir. I'm requesting you highlight.
Okay. 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 Let me do so. Let me do so. I'm going to share my screen and then I'll highlight those few areas about reflection. Okay. Give me a minute. Give me a minute because I have to get the graph. So this is the graph. This is the graph that Moyo had for us. This is the graph from Moyo, and maybe what the teacher has already told us. What I want you always to observe now, like for enlargement, you would have noticed that your center from the question was at 0, 0. So what you do, you can always draw a long line like this. That's when you have a positive scale factor. Like here we had 2. So you first draw a line like that. Now, which point do you want to enlarge? This is the point you want to enlarge. So what you do, get your pair of compass, place it here. Now, this distance you have, whenever you are counting the distance, you start measuring the distance from the center. So since you are going to double it, this is going to be 1. Get the protractor. This is going to be 2. So it is going to be here. In case I want to enlarge this other point, let me say this point. I come from where the center is, I draw a very long line like that. The next thing you do is that get your protractor. This is the point you want to enlarge. Get your pair of compass, measure this distance. Now you start counting your distances from the center here, that this is 1, then this is 2. So you notice that the object is here and the image is here. So all of them are on the same side of the center of enlargement. Now, if it was, let me say, the scale factor was negative, then now that one is a bit different. For the scale factor, when it is negative, then the 2 must always be on the opposite side. So when you are drawing your line, now that line, you would have drawn it somewhere like this. Such that now you measure this distance, that from here up to here, this is the distance that I have to measure. So when I'm counting, I start from here. So I'll count that this is 1, this is 2. Then you place your point here. For this one, it will be this side. Then you count that for this, you first measure this distance, that is 1. This is the distance you're going to measure. So you enlarge it, that 1, 2, and then you place the point at that point. So you notice that the object is this side, and then the image is going to be this side. So the object and the image are on the opposite side. That's when your scale factor is negative. That's what you do when it comes to enlargement. Someone was asking, should I use a pencil or a pen? Now, for sometimes your papers are marked at night. Now, if you feel you are very, very accurate, kindly go on and use a pen. In case you decide to use a pencil, ensure that your pencil is very sharp, that even at night, someone can be able to read your work. Now, when we talk about reflection is like the mirror you have at home. In reflection, when you have an object, let me say this is an object. Reflection means that bouncing back of light. And some of the properties of reflection. If this is my object, I'm going to be seeing my image inside the mirror. But one of the key properties we use is that the distance from the object to the mirror, here, in case this is 4, it is the same distance from the mirror up to where your image is. This is also 4. Now, that is one major thing you need to know. If you don't use this, then you can draw what we call the perpendicular bisector. That if I have this as my point, what I do, I draw my perpendicular bisector, I bisect like this, then I draw a line. Then I measure off from here up to here. In case this is 4, from where the mirror is up to here, I'll also measure off 4 centimeters. Now, our mirror can be placed in different positions. When you go to the salon, you'll find your mirror placed like this. Now, this is what we call the y-axis. The mirror is placed vertically. If you don't call it the y-axis, they can call it x is equal to 0. The mirror can as well be placed like this. This is the y-axis. Or you can call it, this is the x-axis, which you can call the line y is equal to 0. However, your mirror can as well be placed diagonally. This is y is equal to x. But your mirror can as well be placed like this, which is y is equal to negative x for the negative gradient. Now, these are the major 4 ways how your mirror can be placed. It can be placed vertically, horizontally, or diagonally. Now, depending on the scenario that you are dealing with, you need to know that when it comes to under matrix transformation, they may ask you to use the graphical approach or to use the calculation approach. When it comes to the graphical approach, let me say you are using the graphical approach. Let me say you have, this is my line, this is my line, something like this, and maybe this is what I want to, let me just put here. This is something I want to rotate. And they have told me that your mirror is placed along the y-axis. It means that our mirror, let me get a better color. I think let me use, it means that your mirror is placed like this. Now, the next question you ask, here, don't shade, here I'm just showing you, just, what does it mean? Now, if this is your A, and this is your B, and this is your C, what you need to note is that look at A and where your mirror is. Measure off the distance. That here, I have only one box. That means that also from your mirror, the other opposite side, you remove one box. So that point A will be reflected here. In case this is C, I ask myself, what is the distance? 1, 2, 3. So from the mirror, also I'll count 1, 2, 3. So that point C is going to be here. For B, you count 1. So also from the mirror line, you measure off 1. So B is going to be here. And therefore, after, you come and join, come and join, come and join. That's what we call reflection whenever you have the object. If you don't want to do it, what you can do is that you draw your perpendicular. Have your compass here. Make an arc, make an arc. After, place your compass here, make an arc this side, come here, make an arc. Then after, join very well. Get your divider, measure off here, and measure off at same distance from the mirror to where your thing is. In case your mirror, let me say it is placed maybe diagonally. In case it was placed diagonally, then that one is also different now. In case it is placed diagonally, let me say your mirror was placed, let me put here, I put here something, and maybe your mirror was somewhere like this. I'm just using this. If your mirror was something like this, I wanted to have something. Okay, something like that. Now here, in case this is where I have my object, let me say this is where my object is, somewhere here. Now here, in case this is my point A, it means that when your object is this side, your image is going to be this side. Now when you are moving, what are you going to do? Move up to when you meet your mirror line. So I'm going to move 1 and then 2. I will stop here. Now, since you have moved horizontally, when you get reflected, you are going to move vertically. So from here, I'll move 1, 2, and my object will be there. The same thing in case this is, move up to when you meet your mirror line. 1, 2, 3, 4, 5. Then from here, move 1, 2, 3, 4, 5, and then place it there. You do the same thing with this point. 1, 2, 3. Move 1, 2, 3, and place it there. Then at the end of the day, then you join those particular things you have obtained. Now, still under reflection, they may ask you to use the calculation. Let me say they may ask you that you use your calculation for the line for the y-axis. Here now, to come up with the matrices, we use what we call the unit matrix. Unit matrix is that matrix which has like an area of 1. So a unit means 1, meaning that when this is our unit, this one axis, we call it the I-axis. So this coordinate here is 1. Also this coordinate here is 1. So here there is 1, 1, and this one is 1, 1. Now, what happens is that if this is your mirror, let me say it is placed along the y-axis, what happens? That this point here is going to come this side. So it's going to come here. So this is where you're going to have negative 1. Now, this point here is going to come here. So you'll get your image in that format. That is the reflection along the y-axis. Now, if you're writing your matrix, remember this coordinate is negative 1, 0. This coordinate here is 0, 1. And when we are writing our matrices, we always write I prime and J prime. So our I prime is this one along the x. I write negative 1, 0. Our J prime is 0, 1. I write it as 0 and 1. And this is what we call the reflection along the y-axis. Sometimes if a student is forgetting what you do, you need to remember that I can write y-axis like this, such that I know that when I'm writing the y-axis, I start always with negative 1, such that you know that always the first one here is going to be negative 1, 0, 0, 1. In case I'm writing the x-axis, then you just interchange the two. This one becomes 1, negative 1, 0, 0. Now the other two, y for y is equal to x, then that one now you need to just know that that one is going to be 1, 1, is going to be 0, 1, 1, 0. In case it is y is equal to negative x, then that one you know is going to be 0, negative 1, and 0. As long as you know the one for the y-axis, the rest are going to be following. Now, under matrix transformation, still, when we are dealing with any transformation, do not forget that matrix transformation calls in for multiplication. And when you are multiplying, always we have the transformation matrix times the object will always equal to the image. Always have your transformation matrix times the object, you'll always have your image. So that is briefly about what we call the reflection. Then for rotation, maybe what I can bring out is that when the rotation is at the origin, because when you look at this question here, if the rotation is that this rotation we dealt with was not at the origin, but if the rotation is at the origin, then you can go on and use this formula. This is sine theta and this is cos of theta. In case the rotation is at the origin, you can use that formula to get the matrix transformation. Let me say they tell you a positive quarter turn, then you just subtract as long as the center is at 0, 0. If it's not at 0, 0, then this formula does not. And therefore, that means that you are going to go back and use the graphical approach. Whenever you notice that the center of rotation is not at the origin, that is indirectly asking you to use the graphical approach. When it comes to enlargement, if the center is at the origin, then in case you are writing the matrix, this matrix will hold. However, if the center of enlargement is not at the origin, then never use this, where K, this K stands for scale factor. A stands for scale factor. Whenever you find that it's not at the origin, these formulas do not hold. They will always change. Okay, let me take on a hand from Ochaya Fred. Ochaya, unmute. I don't know whether Charlene, now we are on the same page. Ochaya, okay, I failed to get Ochaya. Okay. Okay. I think I'll fail to get. So That is briefly what you can do about
Yes,
those
we
particular.
are now on the same page.
Come again? Okay. Yeah, said
Thank
we
you.
understand. Okay. Okay. So I want you to please take note that whenever you are dealing with these items, make sure that the scoring areas are never missed. When it comes to writing formulas, write your formula, but please make sure that the values you have substituted in the formula are correct values, because you are always awarded for the right answers within the right formula. So look at how has the child substituted in the correct formula. Is the answer correct? And as the child responded, where units apply, we expect to see the units. Even when it comes to the table, when it comes to those statistical tables, please avoid writing, because many of us have crammed that always you must have class. No, always read the scenario. In case the scenario is talking about height, put height. In case it's talking about put time, don't bring things of classes. The same thing with frequency. It's not that always is frequency. Please put what the scenario. In case it is saying number of students, put number of students, then in the brackets put F. And never use F if you have not defined it within the first columns. In case it is time, never put mid value. You put, is it height? You say mid height. Then in brackets, you can put what? X. Now that's when, after defining what X is mid height. Number of students is F. Now that's when you can go on and use your F of X. But never use them if you have not yet defined them. And always ensure that on your graph, the scale is consistent. Ensure that the values you have here are consistent. If it is 2, 4, 6, and the rate. Then the same thing. If the two axes have different scales, please indicate that here I have 4, this is 8, this is 12, and the rest of that. So make sure you have, and never forget to end your graph. Never leave your graph like this and you draw like that. Put the ending point that my graph is ending at a given point. Where applicable, more so when it comes to estimating, estimate the values and make a conclusion. And for estimated values, say approximately and then say 45. Never command yourself or never say equals to that. More so if you have just approximated that particular value. Avoid the truncation. Let me say you have got your answers 2.52 and for you just write 2.5. Carry the decimal point. Whenever you are making any calculations and you have not reached the final value, avoid what we call premature approximations. More so if that value is to be carried, make sure that you write to at least 4 decimal places. If you are still using that value and it's not the final answer, make sure that the number of decimal places are at least 4, such that you are very accurate. However, whenever you have your values terminated early or truncated early, you are going to fall into issues. So avoid those things of rounding off so quickly without you looking at it in the deeper end, because at the end of the day, if you are going to use those values, you need to be very, very careful with them. So please, let's pay attention to that. When it comes to still this element of construct, avoid jumping steps. Some of you, I know you are very gifted. For you to just see something, let me say, you see 4 times 2, maybe plus, maybe let me say plus 6, or maybe plus 2. For you, just come and say, this is maybe 4 times 8, 90, and then you just put 10. Please show all the steps that 8 plus 2, that's when I get what? I get 10. Avoid those things of jumping steps, because what you may be jumping might be the area where they're going to award the mark. So avoid jumping steps. However sure you may be, avoid jumping steps because you are hurrying for something. Now, I want us always to budget for our time. Your paper is for 2 hours and 15 minutes. So make sure that when you are budgeting your time, make sure that your time is well budgeted for. That if the paper is for 2 and 15 minutes, then you need to know that, what am I going to do? That I must budget that my hours are well budgeted for. So please budget for your time very well. Do not just hurry without budgeting for your time. And then maybe what I would like to share with you, one of the last thing is that after these sessions, please identify. When you look at my screen, these are traffic lights. Green is an indicator that it is a go. It means that I want you to identify what are some of those topics you are well conversant with. What are some of those topics that even when they wake you up, you can do it comfortably well? Is it an element of construct now you have mastered very well? That is your green light. So in your book, in your journal, in your summary book, have those topics written down, the ones you are very sure. Then we have those topics in life that are still disturbing us a bit. We are not yet there. Sometimes we pass them, sometimes we do not. Now that one saying that you are not yet get ready to get to the green. Now that is the yellow. So write those topics where you are in the middle, such that you know what you are going to be working on. And when you start working, when your brain is becoming a bit tired, more so now after 9 p.m. you are still pushing. Now that's when you can look at these particular topics that are in yellow. But then we have red. These topics are not entering. You have failed to capture them. They are giving you nightmare. Now those topics are what we call the red light. Write down those topics. And now for these topics, I want you to consult your teachers. I want you to discuss in groups, in pairs. Look out for a pattern that you can read with. Discuss these items. Get these seminar items. Discuss. Share ideas. When your brain is still very fresh, let me say, very early in the morning, you have just woken up and you feel you are very fresh. Now, those are the topics you give time first, because your brain can take in a lot of things. So those are the red light. So they need more time, and they need when the brain is still very fresh. So identify those topics that are red, that are orange, and then the ones that are green, such that now you know you have a reading strategy. Don't just read anyhow. Today you are opening this topic, tomorrow the other, and the other. You have a plan on how you are reading for your mocks. I know you have mocks very soon. Yes. And always ensure that you plan well. Communicate. Have your work well organized. Under the planning phase, make sure that you do not spend more than 30 minutes on each of the items. The moment you spend more than 30 minutes on an item, it is a clear indicator that you are not going to be able to finish your paper. You'll find that this item is demanding, this one is demanding, and this is demanding. And whenever you receive your paper, first scan through and check out which item can I do comfortably well and quickly. Now those are the items you start with, such that you do not waste your time. Because what happens in life, whenever you meet something that is very hard, it's going to signal the brain that, man, things are hard. So what is the brain going to say? The brain is going to start seeing other numbers that are coming, all of them as hardy numbers. That's why always better start with something you are well conversant, something that is going to boost your brain, your morale, such that you can be able to do it very well. But the moment you start with those hardy numbers, by the time you finish, you find that this one has demoralized you already, this one has put you off, and whenever the brain is working on pressure, your thinking capacity goes low, so you are not able to think very well. So you may make mistakes, you may keep on hurrying, and you make wrong choices. When it comes to presenting your work, I know the teachers have already told you, do not present your work like this child. Whenever you are presenting your work, avoid writing work side by side. You have written here, you have written here. Do not. Avoid wasting time underlining. You don't have that time. Please and please don't write your work side by side, but I want you always to have your work. Don't never even divide your page like this. There is no need. But when you are presenting your work, present it like this child, whereby now everything you are writing here clearly flows very, very well. You have already defined what you are going to use. The equations are clearly seen. Units are indicated. Conclusion and responses are seen. You can see the vertical flow of the work. So here marking your work becomes very what? Very easy. So I want to call on you when you are presenting your work, present it in a vertical way. Let it be flowing. Let it be very organized. Communicate. Do not have your work very disorganized. Let your work be well organized. Let it be flow. Use the best handwriting you can ever use. That one will put you on an advantage. Now, with that, unless there is a burning question that maybe we have not responded to, feel free now to do what? To raise your hand, and then we respond to those few questions. Number one, Samuel.
Yep, Master, I have a question where it is about data collection, and you say that we should jump any step, and it is true. But in some areas, for example, they're saying that you look for the middle number, which is x. So we know the steps for it. We get the frequency, we divide out of 2, the interval, that class number. So could we also show all those steps? Because our teachers say we should always show the step where we are looking maybe for the cumulative frequency, how it is coming up, but the others where it is not necessary. So may you clarify something on that?
Oh, now when it comes to that one is very okay. You may not show. For when it comes to cumulative frequency, when it comes to class boundary, when it comes to mid-mark, there is no need. But when you are calculating the mean, median, and the rest of that, show step by step how you are obtaining them. Because always the scores are given to that table. Hope that is okay, Samuel. Okay. Joy?
I was only inquiring about how do we choose the brackets to use in the class? Like how do we choose that we have to use a class boundary of 5 or a class boundary of 10? Like how do you decide depending on the data that you're given?
Okay. Now when it comes to that, allow me to share my screen. Now you are going to find that you are going to have data. Let me just give you a data. Let me say they will give you 40, you have 50, 45, 30, 30, 80, 14, 80, 40, 55, 60, 65, maybe 30, 80, 35, 50, 55. I'm just using this as just an example. 68. Now, what always you do is that identify to get which class to get the interval to use. Number one, identify one, the smallest value among your data set and the largest value. Now, when you look at this data, this is my smallest value. This is my smallest value. Then the largest value is here. Now, what are you going to do? Now, the best class interval to use is either 5 or 10, much as you can use others, but these ones are very easy. Now, the first thing always you do, you test which one of the two will give me a good number of class interval, like classes. So you'll come and say 68 minus 30 divided by 5, or 68 minus 30 divided by 10. Those are the two things. So what are you going to get? That here I'll have 38 out of 5. So 38 divided by 5, here I get 7.6. Here when I say 38 out of 10, I'm going to get my answer as 3.8. Now what you do, you ask yourself, 3.8, it means that the number of classes you can be able to obtain, they are going to, when it is 3.8, these are about 4. It means that when you use a class interval of 10, you can only be able to generate 4 classes. When you use a class interval of 5, this is 7.6. It means that you can be able to generate 80 classes. Now, whenever you are dealing with the classes, ensure that you have at least 5 classes. At least 5 classes. Anything below 5, your levels of accuracy are low. So now for such a case, I'll use my class interval as 5. Now when it comes here to create now my class, I'll always start with my lowest value in the table. So I will say from 30, and then I say what is going to be the next one. Since the class interval is going to be that, then I will say 34. Then I will say this is going to be 35, and then I'll go to the next one. This is going to be 39. This is going to be 40, then 39. This is going to be 44. This is going to be 45. This is going to be 49. This is going to be 50. This is going to be 54. This is going to be 55. This is going to be 59. This is going to be 60. This is going to be, what is that? 59 plus 5. This is going to be 64. This is going to be 65. Then this is going to be 69. And when you reach 69, you will notice that you have ended your classes. So when you count, this is going to be 1, 2, 3, 4, 5, 6, 7, 8 classes, which we got here. But when you decide to use 10, you can only generate 4 classes. So which would not be very good because your data sets are going to be widely spread. Okay. When do you know when to use assumed mean? Now, the question may give you a hint, may say that the question may tell you within the task or the scenario that the school was not sure. However, the head teacher estimated the mean to have to be something of this, and then they may ask you to verify whether that mean was the actual mean. Sometimes they may say, it was assumed that the mean for the class was this and this. Then now, once they give you such, then you will need to know that now for such is going to be calling out for that. So sometimes, depending on what you are dealing with, you'll find yourself that they have given you a hint within the what? Within the scenario that can show you that now here, I'm going to bring in the element of the assumed mean. But always when it comes to assumed mean, there is a small hint that they are going to always give you. Now that hint they give you is the one that you have to use. Most so they will tell you that people are not sure whether this is the mean. People are just approximating this to be the what? To be the mean. Now that one should give you guidance that now I'm going in my question. When I'm going to be dealing with this, I'll have my thing. Another time, they may tell you that the deviation of the data was this and the other. Now, when you see words like deviation, then that one should give you a big hint that if it is a deviation, then that means that there is an idea concerning what? Concerning what? Concerning what? The mean. So that is maybe something that you can look out for when it comes to that. So briefly, that's what you can do in case they have not given you the class interval and you have to create. But I always advise that when you are getting the class interval, go on and use 5 and 10. They are good class intervals. But if you decided to use these ugly ones of 3, 2, what, those ones are very ugly. Now the item I'm showing, this was one of the seminar items for Matigo last year, but this is how they can ask you for assumed mean. So it is assumed that the mean height of student was this, and the student and the school administrator wants to find the average height. So they can ask that question in that what? In that format. Okay, allow me to answer one more. Okay, Samuel.
Now, Master, I'm still having some question about when we are getting the class limit, assuming that our smallest class starts with maybe 29. and we want to get where we're going to start our first class limit from. So sometimes we get confusion when it comes. Some people, maybe 31, let me use that example, 31. So some people say, no, let's start from that 31. Maybe the class interval is of 5. So say 31 up to 36. Or someone says, no, let's use from 30 to 35. So when we are when we are starting our class limit, do we start from the same class where the scenario is starting from, maybe the smallest, or we can even extend down a bit to 30, so that 31 should be covered in?
Now, I would advise that always start from where the class started from, because you having a value in your table that is less than that value, it is an indicator that you have created your own data that was not given. Because if the data tells you that the heights obtained from the field were 110, 100, this and this, and now for you, you come up with something below it, let me say 100, it is an indicator that you have formulated or you have gotten something that was not measured. So if they told that the heights of children that were taken were 110, 100, this and this, now for you come with something less than that, that is an indicator that for you, you were able to measure something that was not being seen. I don't know that you have understood. Samuel, I think it was Samuel. Hope it is okay.
Yes, Master, I've got it. Thank you.
Okay. And lastly, Gus.
Yes, thank you, sir, for this presentation. Our question is that what about when they are given the data and it is in points? How do you handle that data when it is in points? Thank you.
Now, when they give you data, when it is in points, when they have given you a table or when they have just given you scattered data? I don't know that you're still on.
Yes?
When they have given you scattered data or when they have given you the table?
I think even though it is in the table, but the digits have points.
Okay. Now,
yeah.
When it comes to that, allow me to share my screen again. Wait. Now, when it comes to that kind of data where you have points, I think still I'll be a bit more practical. There are things you need to understand. Allow me, I'm going to share this screen briefly because you need to understand and do not cram. In case they have given you a table, now like the table I'm sharing on my screen, this is the table. Dear students, if they have given you a table like this, they have given you mass. This is 9.5, this is 19.5. This is 19.5, this is 29.5. I'm just putting it here. This is 29.5, this is 39.5. Now, when you look at this data that has been given to us, I want you please to take note. The moment you ever observe that the data you are dealing with, these two are the same, 19.5, these two are the same, then you need to go back on the drawing board. Now that one shows that those are class boundaries. Now here what they have given you is class boundary. When you look at when you look at the tables of your class boundary, you will always find out that these two are always what? The same. We call it the adjustment factor is 0. Now here when you are dealing with such data, you need now to know how to get back that now in case I'm going to use some of this data because they say retrieve the original data. You need to know that when I'm getting the lower class boundary, what do? I subtract. This time around, what am I going to do? I'm going to add. So now that one you need to know that now this is going to be 10 and here it's going to be 19. It's going to be, this is going to be, let me say 20. This is going to be 20, 29. Now you need to pay attention. Your data can be given like that. But as long as you identify that this and this are the same, this and this, where? Okay, I think here there was, wait, this 39 and this are the same, 50 and this, then that is an indicator that what has been given to you is class boundary, so you need to know how to work with it. Secondly, if they have just given you points, let me say they have just given you 1.0 to 1.2, maybe 1.3 to 1 point something like that. Now, as long as these two values are not the same, now what is very important here, what usually confuses you, is how to get the class boundary. Now, when you are getting the class boundary, to know what to add and what to subtract, always we can use this, that 0.5 times 10 power negative n, whereby n is the number of decimal places. So in case, let me start with this data you are used to, 40 to 50. Since this value here has 0 decimal place, here where there is n we put 0. So we say 0.5 times 10 power negative 0. So which is 0.5 times here 10 power 0 is 1. So it's 0.5. That's why whenever you have whole numbers, you add and subtract 0.5 because that is the error in that value. In case your data is to 1 decimal point, then where there is n, you put 1. So it becomes 0.5 times 10 power negative 1. So this is 0.05. So now for that one, for your class boundary, you subtract and add 0.05. In case there are two decimal places, then you have 0.05. Now, in case there's 1 decimal place, here you'll have 1 0. In case there are 2 decimal places, here you'll find that you have 2 zeros. Like that. That's what you do. Still, when it comes to getting the class interval, still what you when it comes to generating the values, get the upper minus the lower. In case it is whole number, you add 1. In case it is the other number, you add 0.1. That's how you can deal with such data in case you meet when they are decimals. Okay, I think I have exhausted all the questions that we had. So I want to thank you so much for attending this session. Those who can, kindly have your cameras on. I wanted to take a photo, and I will ask the teachers also to take some photos of the students that at least have been able to attend. I'm going to share next weekend. Next weekend, we have a chemistry seminar. I'm going to share, after taking this photo, I'm going to share the seminar questions in the chat, such that now for you who have been able to attend, you can start there and then to make your presentations, such that when we come in next weekend, we can meet. For any questions that we have not been able to do, kindly members, dear students, do them, take them to your teachers, let the teachers support you, and then everything will be what? Will be very okay. One thing I want us to avoid, dear students, don't take the problem to the teacher. First do, and then take to the teacher and tell teacher, I have tried here and here, but things are not adding up. Then the teacher will say, okay, things are not adding up. How can I help? And then the teacher will be in position to help you with what you can. So please take note of that. I'm going to be, because I feel there is something I need to do. I need to do some editing. Kindly allow me that I will send those seminar items on the WhatsApp groups, and then you'll be able to get them from your teachers, because there is something now I have noticed that I have to edit before I give them to you. But you are going to receive them shortly after these sessions. We want to thank you so much. Teachers, you take some photos for your students where they are. And allow me now to welcome the Principal Education Officer, Mr. Ronald, to officially close off this session. Mr. Ronald? Okay, sorry. Mr. Ronald, you can unmute.
Thank you, Mr. Kaziba. And thank you to the teachers who have supported the students up to this time. Thank you, dear students, for showing interest in learning, and important that you are learning mathematics. Take you a long way, so work hard at it. I have followed most of the discussions, as I said, when I was in Kampala, but now I'm reaching Gulu, and that tells you how long you have been sitting in. And for me, you've added a brick to your learning. I want to wish everybody success in their mock time, and we will see you in all the other engagements. Next weekend we have chemistry, but we shall also have those 2 weeks when we meet every evening from 4 for the different subjects as per the timetable that was shared. Encourage your teachers to stand by you so that they can support you throughout. And we want to see flying colors at the end of the day. I want to wish you a good night and a good week. So we meet again next Saturday. Thank you. And I declare this meeting closed. Thank you.